Well, howdy, everyone. Glad to not see you today. I know that sounds horrible, doesn't it? But if you had your videos on, I could say, glad to see you. Maybe we can do something about that after the tour. But I'm happy to see so many of you here today. Just looking what kind of where things are right now. I think it would be okay. Good afternoon to you too. I think it would be okay if you have some friends or someone else that you think you might want to invite. I think that would probably be okay to do that. So feel free to give them a call, give them the Zoom ID info. I know the tour says booked, says that it's full, but a lot of times people have more important things going on or something pops up and they're not able to make it. And we certainly would like everybody that would like to join the tour be able to do so. Do have to warn you today, though, you're guinea pigs. Yeah, this is the first time that this tour has been given. So hopefully it goes well. Hopefully it makes sense. I certainly am looking forward to your feedback at the end in our question and answer session. That way we can make it better. I can improve the tour. So be thinking of your really, really bad puns, your really, really bad dad jokes. All of those would be greatly appreciated to be able to add to the tour. So I will join you back here in about 7 or 8 minutes. Just again, wanted to welcome everyone and to let you know that it's okay to invite somebody else if you want to. Go ahead and give them the Zoom info. Well, greetings to all again. So happy that you were able to join me here today. The chat, I got a message about my lab coat. This is actually my lab coat. This is the lab coat that I wear. I see it, but this is the real thing. Spot and all. I've got a little spot right here. I don't know if you can see it or not. I guess it's low enough. It's out of the camera. Okay, good. Well, I want to welcome everyone to today. It looks like if you're in a position where you'd like to invite somebody, please feel free to do that. Just give them the Zoom information. Doesn't matter that it said the tour is full. Sometimes people will sign up in advance and then something happened. So we usually figure that not everybody's going to make it. So it's okay to call someone if you think they would enjoy the tour as well. I am a punctual person. I very much like to get started on time, and it is now, according to my clock, time. So I want to welcome you all to this virtual tour. This is a tour of the Smithsonian's Natural History Museum, National Museum of Natural History. Let me say that right, in Washington, D.C. Now, first of all, we ask that you please do not record this tour. Please don't publish any parts of it on social media. There's a lot of different reasons for that, but mainly we ask that you please don't do that. You can take notes, but I wouldn't. I know that goes against the norm, but there's so much information in this tour. I would hate for you to miss the enjoyable parts of it because you're getting hand cramps. I promise you there will not be a test. I know I fight that urge as a science teacher of 27 years, but there won't be a test at the end. So just enjoy the tour, sit back and enjoy it. And if you miss things, then just take it again. It's coming out. The new list of tours are now available for the next couple of months. I will be taking a little 3-week hiatus at the end of the beginning rather of July. But then this tour, along with its predecessor, which is part 1, is also available. And so please feel free to sign up for those tours as well if you think that you might enjoy them. But I will have a question and answer session at the end to give you an opportunity to ask me something that maybe I didn't do a real good job of explaining, or just a chance to share some information about the tour, how you liked the tour, what you thought, or maybe, hopefully give me some bad jokes, some bad puns as well. A lot of tours going around right now, but very few of them are actually tours of museums that are science museums. So I thought, since I'm a science teacher, I've been a science teacher for quite some time, that I would take you on a tour of a Museum of Natural History, which basically is a science museum as opposed to an art and an archaeological museum, which is what most of the other ones are. I have done a tour in a previous tour called Misled by Artful Deceptions from the Louvre in Paris, France, which is the world's most visited museum. At least it was up before the pandemic. I did that tour. And so now the tour that I'm looking at doing is of the most visited science museum in the world. So let me go ahead and put this information up there. Let's see. I tell you what, let me share the sound. Okay. All right. I'm hoping that you can see Henry here. And if you saw part 1, you know this is Henry. So if you would be so kind, in the chat, let me know if you can see this okay. Can you see Henry okay? All right, I'm getting some chats coming in going, yes, 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 yes. I guess everybody's a good yes. Okay, thank you. No need to let me know. I got it. Thank you so very much, okay, for letting me know. So this is our tour of the Smithsonian part 2. Okay, and so here we will be looking at the information that's a little different from part 1. Hopefully, if you saw part 1, you enjoyed it. that you would want to see part 2. If not, then part 1 will be available coming up. I think it's going to be the end of next month, but part 1 is coming, and then part 3 is in the writing. We'll finish it up with our last one. I'm in the process of putting that one together as well. Okay. All right, so let's go ahead and get started now. In part 1 of our Creation 101 tour, we visited the Rotunda, where you see Henry here, and we looked at exhibits on the first floor of the National Museum of Natural History. But now, okay, let's go up to the second floor. I hear it rocks. The Smithsonian's mineral and gem collection. You see what I did there? Rocks. Okay, the Janet Annenberg Hooker Hall of Geology, Gems, and Minerals. It consists of about 350,000 mineral specimens and 10,000 gems. Makes it one of the largest of its kind in the world. Now, let's talk a little bit about gems and jewels and precious stones and such. All right, now, a jewel might be a precious stone, but it differs from a gem. Now, a gem is technically a cut and polished precious or even semi-precious stone, or it can be a decorative ornament made of precious metal, usually gold, silver, that can be set with such stones. Today, the diamond, the emerald, the ruby, and the sapphire are strictly considered to be precious stones, whereas any other rare, beautiful stones, they might be viewed as semi-precious. But the Bible, and looking at the Hebrew term rendered precious stone, well, it can actually have a little bit of a broader application. And we see here at Ezekiel 28:13 that it says, "You were adorned with every precious stone, ruby, topaz, jasper, chrysolite, onyx, jade, sapphire, turquoise, and emerald." So you see some mentioned here that are not technically in today's world viewed as precious stones. Now, these precious stones that you see here are distinguishable from other minerals, chiefly because they are very rare, they're very beautiful, and they're quite durable. And I guess I probably need to share this with you. It was getting close to my wife's anniversary, and okay, she went around leaving all these jewelry catalogs. You see them here, hanging around the house, all these magazines and such. And I'm no dummy. Okay, I got the hint. I bought her magazine rack. When the ancients rounded and polished precious stones, generally they don't seem to have angled them or faceted them like you see the craftsmen doing in modern times. So most of the ancient jewels and gems that you see are just rounded and smoothed. We'll talk a lot more about how they've been able to take and actually chip off pieces to make them more beautiful because of what they can actually do with light. Now, jewels are mentioned in the Bible in regard to the clothing of the high priest. His official attire would include jewels that included onyx stones and setting stones of the ephod and for the breastpiece. The high priest's ephod had 2 onyx stones on the shoulder pieces with the names of 6 of the 12 tribes of Israel inscribed on each stone. So, as you know me, I love to do polls. So why don't we start off with a poll here and see. Let's see, let me open up the breastpiece of judgment poll. And it says, which precious stone was not found on Aaron's breastpiece of judgment? You think they left off the diamond, the emerald, the sapphire, or the ruby? Notice these are the 4 technical precious stones. Wow, this is a sharp group. This isn't even close. I expected some of you to miss it. I'll share the results with you here in just a second, but wow, you are on top of it, that's for sure. And I'm so happy to see so many of you doing the polls. I love doing the polls myself. If you've had a tour with me before, you've heard me brag about how good I am at the polls, doing them. I always get them right. Of course, after I've seen the tour 4 or 5 times. And hopefully you're the same way, but you can't say that because this is the first time that I have done this tour. So we'll end it right now, and let me give you some serious props. I'll share with you the results. 92% of you were right. Yeah, fantastic. It was the diamond. There's no diamond in that. Now, you stop and think, were diamonds around? Well, yeah, diamonds were around, but they weren't faceted. They weren't polished. They were just little stones. And what are you going to use to make them smoother or shine? You can't, because the diamond is the hardest material. There was nothing that they could use to do anything with the edges. The breastpiece of judgment, there were 12 different gems. In the first row, you see the row that had a ruby, there was topaz, and there was emerald. Those were in the first row. The second row had turquoise, sapphire, and jasper. The third row had something called the Leshem stone. Okay, not sure exactly what that was. And there was agate and amethyst as well, as you can see here. Some people think, well, maybe the Leshem stone was amber, the petrified little critters that's found in the hardened tree sap, or maybe it was something called hyacinth or opal. I'm sorry, yeah, hyacinth. Maybe it was opal. You're probably familiar with opal. Maybe it was tourmaline. They all might have been possible, but nobody really knows for sure. In the fourth row, you had chrysolite, onyx, and jade. And the name of one of Israel's 12 tribes was inscribed on each of these stones. And then they were set with settings of gold in their fillings. Now, speaking of gold, well, they got that here too. Other samples of gems can be seen in the museum as well. All of this is gold. Some of it found displayed here exactly how it was found and was discovered in this particular shape, this particular form. Now, let's look at some other gems at the museum. This is the 858 carat Gachala emerald. It was found in Colombia in 1967. Very, very rarely do you see emerald crystals of this size and then this superb color still around. Usually they get cut real quick into gems. A man named Harry Winston donated the Gachala emerald to the Smithsonian in 1969. We're going to talk a lot more about Winston a little bit later. The Hooker Emerald Brooch is an emerald brooch designed by Tiffany and Company. The Hooker Emerald was extracted from an unidentified mine in Colombia, a lot of emeralds in Colombia, in the 16th or maybe the 17th century. The emerald was made part of the crown jewels of the empire during the reign of a Sultan Abdul Hamid II. He was the last Ottoman Sultan that ruled with absolute power. He actually had it put into his belt buckle and wore it around his waist. Now, although not at the Smithsonian, I thought you might be interested to know that the world's largest cut emerald weighs 25 pounds. It'd be kind of hard to keep that on your finger, wouldn't it? Valued at about $1.15 million. It's called the Teodora, or Gift of God in Portuguese. Was mined in Brazil, and it was sold to an Indian buyer, but very, very little is known about the stone's actual origins. Rubies. Rubies are also represented here. At 23.10 carats, the Carmen Lucia ruby is the largest faceted ruby. Now, faceted means it's been cut. So you have the little triangles that you can see. You have the shapes. Okay? So when you see that term faceted, each of those little windows, if you will, is called a facet. Okay? So it is the largest faceted ruby that's in the National Gem Collection. Also one of the finest, largest faceted Burmese rubies, as they're known. Of course, the country of Burma is now known as Myanmar, so it might be called a Myanmar ruby. This magnificent ruby was actually a gift to the Smithsonian and the people of the United States in 2004, and it came from Dr. Peter Buck in memory of his wife, Carmen Lucia Buck. Now, with its rich red color and well-defined star, this is also a ruby. This is the Rosser Reeves Star Ruby, and it might be the largest and the finest star ruby in the world. The Rosser Reeves star ruby is from Sri Lanka, but its earliest history really isn't known. Rosser Reeves, whose name it now bears, he carried around with him and he claimed it was his lucky stone. So he carried around it in his pocket, referring to it as his baby. Well, he actually donated it to the Smithsonian in 1965. Renowned for its impressive size, intense color, and its very, very sharp star, what's called the Star of Asia is one of the world's finest star sapphires. Now, all the ones that you're seeing here are at the museum. You can actually see them in the Smithsonian Museum here. The star forms when titanium atoms get trapped inside the growing crystal. And as it cools, those atoms form these needle-like crystals. They orient themselves in 3 different directions. But when you cut it right, the light reflecting off of 3 sets of these needles produces this 6-rayed star. The Star of Asia also came from Sri Lanka. The magnificent 423-carat Logan sapphire was cut from a crystal that was mined in Sri Lanka and is one of the world's largest faceted blue sapphires. It's the heaviest mounted gem in the National Gem Collection, even larger than a very famous gem we're going to talk about here in just a second. The Logan sapphire was a gift to the Smithsonian from Rebecca Pollard Logan, hence the Logan name. Now, let's look at a very, very famous gem, the Hope Diamond. The famous Hope Diamond, this is actually the display that you see, is thought to have come from India, they think. Now, it has boron in it, and boron is what gives it its very, very rare blue color for a diamond. In 1666, French gem merchant Jean-Baptiste Tavernier, he bought this very rare blue colored diamond and he sold it to Louis XIV. Remember him? He was the Sun King, the one that lived in Versailles. So it was cut into a triangular stone weighing 68 carats. Then in 1792, it got stolen. Now, this was when Louis XVI and his famous wife, Marie Antoinette, while they were awaiting execution, the diamond was stolen, never showed up again. In 1830, the 45.5-carat Hope Diamond, now that's how big it is now, the 45.5-carat, remember before there was the stone that was 68 carats, this 45.5 one shows up. The question is, was it cut from the larger one that had belonged to Louis XIV that had been stolen? Well, a lot of people think so. The stone was bought around 1830 by a rich London baker named Thomas Hope. Okay, you see the connection there. It stayed in the Hope family for a while, but then they sold it. And it actually saw a lot of different owners. There were sultans of different countries. There were wealthy socialites, diamond jewelers. A lot of different people actually owned the Hope Diamond for some time. And the rumor came about that perhaps it was cursed. Well, it became the possession of diamond merchant Harry Winston. Remember, I mentioned him earlier, in 1949. He donated it to the Smithsonian Museum in 1958. Now, this is a true story. My wife and I are actually looking at the Hope Diamond. We are there in Washington, D.C. She takes a picture of it and she texts it to one of her friends, along with the, "Could this be my next anniversary present?" A friend responded, "Keep hoping." Okay, hadn't happened yet. All right, most uncut diamonds are actually 8-sided, transparent or translucent, which means they're not completely transparent. They're made almost totally of pure carbon. And diamonds are thought to have been formed a long time ago when the Earth's carbon was subjected to great pressure, great heat. A lot of the early diamonds that were found in stream beds, but now in modern times, they are usually mined from rock formations that are down deep down in the earth. The Foxfire diamond seen here was temporarily on display at the Smithsonian. It's not there now, but it was before. It's 4 times bigger than the Hope Diamond at 187 carats. It was actually discovered in Canada. Now, if you've been following the news, you'll notice this past week, they discovered a new diamond in Africa that is some 1,100 carats. That's the third largest diamond ever. But here's the biggest one. This is the Cullinan diamond. This is the largest diamond ever found. It was 3,106.75 carats, discovered in South Africa in 1905. Okay, here is a replica of that diamond. Looks like a big piece of ice, doesn't it? Of course, that's not the real thing, because the Cullinan diamond has been cut up, as I'll share here in just a minute. It eventually yielded two enormous, high quality, beautiful stones. Okay, and you see the two stones here. One was 530 carats, the other was 317 carats. Well, where are they today? Well, maybe you've seen them before. They're part of the British Crown Jewels. Yeah. And then even that, the other stones, as you see, the other pieces rather of the Cullinan diamond were actually made into other pieces of jewelry. And so you can see all of those at the top put together formed the original Cullinan diamond. So have you ever wondered about the crown jewels? I mean, that's a lot of money. If you look carefully, you can see the largest one there in the staff that the queen holds. The second you can see in the crown itself down at the bottom. It's underneath this ruby. It's down here. Okay, both of them huge, beautiful diamonds. But you ever wonder who actually owns the crown jewels? She does. Yeah, Elizabeth, they're hers. She owns all of the crown jewels. Now, the diamond can be viewed as an example of God's power. It's the hardest natural mineral that's been discovered. It's among the most valuable of gems. So let's take a look at some examples in the Bible where diamonds are actually mentioned. Now, why are they mentioned? Not so much for their beauty, but for their hardness. You see, Jeremiah 17:1 says here that God referred to the use of diamonds for scratching or engraving hard materials when he said that the sin of Judah is written down with an iron stylus, with a diamond point. It's engraved on the tablet of their heart and on the horns of their altars. All about the strength of the diamond. In another example, we see the house of Israel had become very, very obstinate, become very, very hard-hearted. So God said to Ezekiel, he said, look, I have made your face exactly as hard as their faces, and your forehead exactly as hard as their foreheads. It says, like a diamond, harder than flint, I've made your forehead. So again, diamonds mentioned in terms of their power, in terms of their strength. So what makes a diamond, or any faceted gem for that matter, sparkle the way that they do? Well, the short answer is that they are expertly cut and polished to maximize the diamond's natural brilliance. All right, full answer, it's a little bit more detail. In the old days, diamonds were cut or faceted on tools like this. Then they were cut and then actually polished using very, very fine diamond wheels, since the only thing that can polish a diamond is another diamond. And this is when you actually began to see diamonds in their most beautiful form. But now, this is actually a diamond cutting machine. This is a laser cutter. Most diamonds are cut by lasers that are controlled by computers. Now, diamonds get their brilliance from three different things. All right, I'm breaking into a physics lesson here. We have reflection, refraction, and dispersion. So reflection is the light that hits the diamond is immediately bounced back up. It gives it its instantaneous shine. Now, while this glimmer is impressive, it's only the very tip of the true radiance that a diamond displays. Only a position of the light hitting a diamond is reflected. The rest actually travels through the diamond. Now, as the light moves through the diamond, it gets scattered or fractured. This is what's called refraction. Bounces around inside the diamond until it finally comes back out of the diamond. And this creates the sparkle that diamonds are known for. So this is the refraction part. In essence, diamonds are tiny, complicated little prisms The light enters through the top and then is angled around the inside of the diamond before being aimed back towards the top and out through that surface there. So this creates that rainbow effect, right? This is known as dispersion, and this adds to the brilliance. This refraction or dispersion also creates natural light and dark areas in the refracted light. So the diamond's going to actually have some areas where it looks dark in those spots, depending upon where the light hits along the different planes inside of the diamond. But those dark areas of the diamond, well, you know, they might seem to be counterproductive, but really, you got to have them for the diamond to be as beautiful as it is, because they're what's needed to get the diamond's trademark brilliance. You see, the dark magnifies the intensity of the light. It's like a candle. The flame always appears brighter in a dark room than it does in a lighted room. You think about that. Now, same flame, but in a lit room, it's not nearly as shiny. But in a dark room, it looks so much brighter. Well, it all comes down to contrast. You see, a diamond without contrast, it's still going to shine the same, but the shine is going to be significantly less impressive if it didn't have that dark to shine against. It would be missing the characteristic fire that diamonds need in order to shine. Now, the cut also determines just how brilliant a diamond is. It's really, really important. If the shape is too deep or the shape is too shallow, a lot of that light's going to get lost. It's just going to go out of the diamond without bouncing around as much as it could on the inside. A bad cut would let the light slip out of the bottom of the diamond or would bounce out too soon. To a lesser extent, the shape of the diamond also determines the shine. Now, these are the cuts that enhance the brilliance of a diamond. By using the natural properties of the diamond and the complex angles to not only get to the best gleam, but to also assure that the actual shape of the diamond is also aesthetically pleasing to the eye. The clarity of the diamond affects its shine. If you have blemishes on the surface of the diamond or inside of it, that's going to limit the amount of light that can enter or bounce around inside of the diamond. Inclusions prevent the light from moving freely within the gem. So inclusions are considered to be chunks of carbon that didn't completely get compressed. These imperfections are kind of like stop signs or like speed bumps. They affect how the light travels. Fewer imperfections means a more brilliant diamond, and there is nothing or nearly nothing to detract from the shine and the sparkle. So it's not easy to get a diamond to sparkle and shine in exactly the right way. Now, you got to have trained professionals, have to know just how to cut and polish each of those stones to get the best result. You can see the results of this effort every time you notice the way a diamond casts this beautiful display of light and color as it's moved this way or it's moved that way. They call this scintillation, the intense array of light and colors. That's a large part of what makes diamonds such a valuable and cherished gemstone. Speaking of diamonds, I asked my wife if she'd like a new diamond ring to celebrate our anniversary. And you know what she said? She said, nothing would make me happier. So I got her nothing. Oh, okay, not really. Settle down. All right, another example of God's artwork that's viewed as valuable is the pearl. Okay? And so these are actually pearls that are found at the Smithsonian. But why don't we take a second and watch the following video, learn a little bit about pearls.
Few places on Earth remain as untouched as Australia's northwest. This coastline is one of the last pristine places remaining on our planet. Between Broome and Darwin, the coast is as wild today as it was when Europeans settled the continent over 200 years ago. Thousands of miles of uninhabited wilderness where the ocean teems with life. Some we know, and others whose secrets are hidden in the deep. Like this creature, Australia's South Sea pearl oyster, also known as the silver-lipped oyster. Although it's not much to look at on the outside, on the inside, it has the ability to produce one of the most valuable gems known to mankind. Any mollusk that produces a shell can produce a pearl. That includes abalone, marine snails, clams, mussels, and oysters. The South Sea pearl oyster that lives here produces the cream of the crop. It's a solitary creature that can grow to around 1 foot, living for up to 40 years. As a result, the pearls it creates are the largest, most lustrous of all. In recent years, a single Australian South Sea pearl was sold for over $1.5 million. The notion that a pearl always forms when a grain of sand enters the creature is a myth. Another possibility is that some tiny organism invades the creature and disrupts the cells in the mantle. Then, something miraculous happens. The oyster begins to secrete a smooth crystalline substance known as nacre. Nacre, or mother of pearl, is made of the same material that forms the inside of the shell. This combination of calcium carbonate and protein is both lighter and stronger than concrete. It takes several years for thousands of layers of nacre to build up and create a smooth, iridescent gem. But it's a rare event. A pearl of value is found in less than 1 in 10,000 wild pearl oysters.
Okay. Theories about pearls are as old as the pearl harvest is itself. The ancient Chinese called it the hidden soul of the oyster. The Greeks imagined that pearls were formed when lightning entered the sea. The Romans fancied that pearls were the oyster's tears. Now, all of this only highlights the mystery and the rarity. Now, even as recently as 1947, out of 35,000 oysters that were harvested by a crew in 1 week, only 21 actually had a pearl in it. And of those, only 3 were nice enough or large enough to sell. So you can see that natural pearls are very rare. So they're very, very valuable. They were the most sought after of gems up until the technique of polishing precious stones came about, until they could actually adjust them. But just what you find strictly from nature, they were it for a long time. During the Romans' time, General Vitellius, it's been reported, actually financed an entire military campaign by the sale of just one of his mother's earrings. And part of that is because sometimes it can be really, really hard to get the pearl out of the oyster because oysters are so shellfish. Now, the Bible at times alludes to the preciousness of pearls in a very illustrative way. With reference to the surpassing value of true wisdom, Job said that a bag full of wisdom is worth more than one full of pearls. The pearl is also used in an illustration by Jesus. Again, the kingdom of the heavens is like a traveling merchant seeking fine pearls. Upon finding one pearl of high value, he went away and promptly sold all the things he had, and he bought it. So the Bible does make reference to pearls. And as the world moved into the 20th century, the gorgeous natural pearl remained popular with royalty and with rich people. They were the only ones that could afford them. They were incredibly expensive, and that kept them out of the reach of common people. But all of that was going to change. It changed with the advent of what's called the cultured pearl. Now, a cultured pearl results from the process by which a pearl farmer actually encourages the mollusk to make a pearl by inserting an irritant. that's called the nucleus into the mollusk, and then kind of grows or cultivates the pearl on a pearl farm. Cultured pearls, they're real pearls now. They're real pearls. They're formed the very, very exact same way, but they weren't formed by an accident of nature. They weren't formed by a little grain of sand accidentally getting into the pearl or some little microorganism. Most pearls that you see today are actually cultured. Cultured pearls can be made by saltwater oysters, or they can be made by freshwater mussels. And specifically shaped pearls can also be made when that shaped nucleus is embedded in the oyster or the mussel. So they took a little star-shaped piece, put it inside of an oyster, and it formed the star-shaped pearls that you see here. Now, here at the museum, we find the Hope Pearl. Okay, name sound familiar? Yeah, same family. Thomas Hope was Henry Philip Hope's nephew. Now, 19th century gem collector Henry Philip Hope owned nearly 150 natural pearls, of which the best known was the Hope Pearl. Now, this is a very large natural pearl. It's uniquely colored. It's graded from a dark bronze all the way to white, probably what's called a blister pearl. And a blister pearl is a type that grows attached to the mollusk's shell and not in the very middle of the oyster. Just about 10 years ago, a Filipino fisherman made an amazing discovery in the sea off the coast of the Palawan Island. Now, this is a 2-foot long, it's 26 inches to be exact, pearl was inside of this giant clam. He took it home and he hid it underneath his bed, didn't really know what to do with it, and then his tiny home burned down. But 75-pound pearl, it survived. Now, according to officials in the Philippines, the pearl has been verified at 26 inches in length, 12 inches in width, and weighing nearly 75 pounds. Its value, paltry $100 million. Okay. Now, in case you didn't know, and this would be for those receiving pearls, you can tell the difference between fake pearls and real pearls. You can't always do it by looking at them, but you can do it with the tooth test. You actually take the pearls and rub them across your teeth. If they feel kind of gritty, they're real. If they feel real smooth, they're not, and somebody's in trouble. Okay. So now that I've given you guys out there something to think about for your next anniversary, okay, let's go ahead and move on now. Around the corner from the Hope diamond is the moon and the meteorites and the solar system gallery. So why don't we start out our investigation of the moon? Let's do that with a poll. All right, let's see. Let's go to the moon. And the question is, which of the following facts about the moon is not true? So each month's full moon has a different name. The moon has moonquakes, similar to earthquakes. The moon always shows Earth the same face, and the moon is made of green sheets. One of those is obviously not true. And I forgot to mention that if for some reason the poll does not go away, then just click the little button at the bottom that says close, or the little X in the top right corner, and that poll will leave your screen. Sometimes I don't always remember to take it off, so if I don't do that. Okay, well, obviously I was not able to fake you out. We'll end the polling. And yeah, 91% of you, of course, the Earth is not. Well, we'll talk about that here in just a second. Let's talk about some of the other answers, though. The first one was each month's full moon has a different name, and that's true. A full moon in January, they call it a wolf moon, after the howling of hungry wolves in the dead of winter. Other full moon names include the harvest moon. You might be familiar with that song. Shine on harvest moon for me and my gal, right? And and that always occurs in September. The strawberry moon is in June. The cold moon is December. National Geographic gives the Native Americans credit for the full moon naming system that we use here in North America. And yes, the moon does have moonquakes. They're caused by small distortions of the entire planet. Sometimes they're called solid body tides. They're vibrations from the impact of meteorites and thermal quakes caused by the expansion of the very, very cold crust when it first gets illuminated by the morning sun after it's been in deep freeze for a couple of weeks. Now, this is all according to NASA. Additionally, shallow moonquakes can last up to 10 minutes. Now, if on Earth, the vibrations from such a shake, they could shift very, very heavy furniture. In fact, on Earth, water stops quakes from lasting more than a few minutes as a general whole. Now, the next choice is the moon always shows Earth the same face. And yeah, that also is true. You see, the moon is in a synchronous rotation with the Earth. It rotates at the same speed it revolves. It's very, very, very rare. So they say there is this dark side of the moon. Well, technically, it's not always dark. There are times when it's lit up. We just can't see it. So really, the far side of the moon is probably a better term for it. And then, of course, our final answer, the moon is made of green cheese. Now, that's not true, unless, of course, it's Munster cheese. Okay. Now, the Bible says that the moon is the lesser luminary for dominating the night. And it was provided by God as a means of marking appointed times. That's according to the Bible. So the Hebrew word for moon is closely related to the Hebrew word meaning lunar month. And it all starts with what's called a new moon. Since the lunar month always starts with the new moon, that term new moon came to mean month, okay? New moons occur when the moon is directly between the Earth and the sun. So you can't see it. You don't see a new moon. As the illuminated side of the moon faces away from Earth, unless you have a solar eclipse in which the moon passes directly in front of the sun, you don't see a new moon. Now, since the average time from new moon to new moon is about 29 days, 12 hours, 44 minutes, the ancient lunar months had either 29 or 30 days. So let's learn a little bit more about the phases of the moon, okay? One dark night, I sat in my yard and I tried to figure out all of this stuff about the phases of the moon. I was out there for a long time, and then it dawned on me. Get it? Dawn? Okay, maybe this video will help.
For centuries, man has been intrigued by the moon's changing face. Sometimes it's high in the sky. Some nights it's a sliver. And other times it disappears completely. But this cycle becomes predictable as the moon's phases repeat every month. The Sumerians, Chinese, and Babylonians depended on the moon's cycle to determine their days, months, and years. And the moon's phases still mark the beginnings of Jewish and Muslim holidays. So what causes the moon to have phases? And why is its cycle consistent? Phases represent the illuminated portion of the moon that we see from Earth. As the moon begins to orbit Earth, the sun's light reflects off the moon, causing a different portion to glow. The moon has four main phases. New, first quarter, full, and last quarter. It takes about 1 week for the moon to change from one of these phases to another. In between, the moon is either a crescent, which means it's less than half full, or gibbous, which is more than half full. When the moon appears to be growing, we say that it is waxing. If it appears to be getting smaller, it is waning. During a full moon, if the moon, earth, and sun align, and the moon passes through the earth's shadow, a lunar eclipse will occur. But since the moon's orbit is inclined about 5 degrees to Earth's, the moon normally passes either above or below the Earth. The best time to observe the moon is during its quarter phases, because the terminator, which is the line that separates light from dark, dramatizes the moon's surface features. You'll be able to see mountains, craters, and scarps in the most contrast and sharpest relief.
Okay. Now, in the 4th century of our Common Era, a standardized or continuous calendar was established so that the Jewish months came to have a certain number of days more or less. And you can see here an example of that. Nisan the 14th, when the moon was approaching fullness, about halfway through its orbit now, that marked the time of the celebration of the Passover, and also became the time of the institution by Jesus of the memorial supper, or the Lord's evening meal, commemorating his death. Now, it occurs on the first full moon that follows the spring equinox. Maybe you've heard that expression before. The term equinox means equal night. That is when the amount of daylight is approximately the same as the amount of darkness. You have one of those in the fall as well. A full moon in March, well, that was called a worm moon, also called Lenten moon, a crow moon, a crust moon, a chaste moon, a sugar moon, and a sap moon. A lot of different terms for the full moon. Now, worship of the moon was very common during the time of the ancient nation of Israel. The Bible mentions that Job was living among moon worshipers. Babylonians, the Canaanites, the Sidonians, the Midianites, Egyptians, and the Greeks, they all worshiped the moon. Moon worship, in fact, extended all the way to the Western Hemisphere, where ancient ziggurat temples dedicated to the moon have been found in Mexico and Central America. In English, the second day of the week still derives its name from the Anglo-Saxon worship of the moon. Monday, originally meaning moon day. Now, Psalm 121:6 has been held by some to indicate a belief in the idea of illness that might be caused by exposure to the moonlight. As the scripture said, by day, the sun will not strike you, nor the moon by night. Now, this is from the Latin luna, meaning moon. The word lunatic is actually used in the King James Bible at Matthew 4:24 and Matthew 17:15. You see, this expression comes from a Greek word that literally means be moonstruck. In modern translations, it's actually rendered by the word epileptic. And of course, there's the famous man in the moon. And no, of course, moon's not made up of green cheese. This moon being made up of green cheese is a statement referring to a fanciful belief that the moon is made out of cheese. Now, originally, it was a proverb for credulity. Now, credulity is being ready to believe something that's true without any evidence at all. In fact, this expression, the moon being made out of green cheese, has been around since 1638. Now, there have been many songs about the moon. Maybe you're familiar with Moon River, How High the Moon, Dancing in the Moonlight, I'm being followed by a moon shadow, right? Just to name a few of them. Well, Dean Martin had a hit song called That's Amore back in 1953. Remember it? And you probably remember this very famous line. Sing it with me.
When the moon hits your eye like a big pizza pie, that's amore.
Right, but did you know that there were some other verses that didn't make the cut? Verses you probably never heard of before. For example, when an eel bites your hand and that's not what you planned, that's amore. When your horse munches straw and the bales total 4, that's some more hay. When your sheep go to graze in a damp, marshy place, that's amore. When you ace your last tests like you did all the rest, that's some more A's. When your chocolate gram is so full and so crammed, that's, you know this one, some more. When you've had quite enough of this dumb rhyming stuff, that's no more, eh? Okay, with that, let's take a break. You deserve it. Get up and refresh what needs refreshing, empty what needs emptying, fill up what needs filling up. I'll join you back here as we play a little museum music. I can't get enough of Baby Elephant Walk by Mancini. Let's hear it again. Feel free to dance. Okay, well, I hope you enjoyed that, and I hope you enjoyed the first half of our tour. Give you a chance to kind of settle in here a little bit as we move around. Now we're going to move over to the section of the museum that is devoted to meteorites. So let's start by defining some terms now, okay? A small object that's flying in space, that's called a meteoroid. If it makes contact with the Earth's atmosphere, we call it a meteor. And if it passes through the Earth's atmosphere and lands on Earth, then we call it a meteorite. Okay, so we have some different terms. Now, you might ask, why is a weather person called a meteorologist? Did they study meteors? Well, not all of them. Most of them do the weather, right? So the point is, the word meteorologist actually comes from the Greek meteoros, which means lofty or high in the sky. It comes from meta, meaning above, and eor, meaning to lift up. And of course, ology being the study of. So a meteorologist studies stuff up in the sky. And usually that would be clouds, right? And so hence we have our term and the connection. So if it's up in the sky, it's a meteor something. All right, so meteoroids can become either meteors or meteorites, depending upon whether they burn up or they make it through the Earth's atmosphere. So let's look at those that don't make it to Earth now. These are called the meteors. Now, meteors are sometimes called shooting stars, but of course, they're not stars. What are meteors? Where do they come from? Well, actually, they have a lot to do with comets. Yeah. Halley's Comet, a very, very famous example, swept by the Earth in 1986 on its 76-year-long elliptical journey around the sun. And because comets apparently consist mostly of ice and dust, they're sometimes called dirty snowballs. And when a comet approaches the sun, its surface warms up and it releases gas and dust. And it's that dust now. Most meteors are actually about the size of a grain of sand. I'll say that again. Most meteors, most shooting stars are about the size of a grain of sand. A few are a little bit larger. They might be the small pebbles. So imagine how much energy there is in such a small piece of meteor, so you can see it so clearly, it being so far away, it being so bright in the night. More about that later. Now, in a few cases, a comet's orbital path might intersect that of the path of the Earth. And this means that the Earth is going to meet the same trail of dust each time it plows through the comet's orbit. And when that happens, the tiny meteoroids now, they plummet into the atmosphere at very, very high speeds, sometimes up to 44 miles per second, at 71 kilometers per second. When the Earth crosses the comet's path now, the meteors can shoot out in all directions from the same point in the sky. We call that a meteor shower. The two most famous meteor showers are the Perseid, because it's found in the Perseus constellation, and the Orionid, which is found in the Orion constellation. Now, scientists figure that worldwide there are some 200 million visible meteors in our atmosphere every day. These meteoroids that do make it to Earth are called meteorites. Now, you can see several examples of these at the museum. In fact, more than 90% of meteorites are made out of rock, while the remaining consists wholly or partly of iron and nickel. Those depressions or those bumps in the meteorites actually have their own name. They're called regmalips. This meteorite that you see was actually used as a doorstop for some 30 years until somebody let the owner know what it was. He then sold it for about $100,000. Now, it's not difficult to believe that our planet has been hit by large objects raining down from space in the past. Proof of these impacts can be found in the more than 150 discovered craters that pockmark Earth's surface. Some of them are very, very clearly visible. Others can only be seen from aircraft or satellites, and still most of them have long been buried or are on the ocean floor. In Arizona, in the United States, an iron meteorite gouged out what's called the spectacular meteor crater. This is a hole nearly 4,000 feet, 1,200 meters across, and 600 feet deep. That's 200 meters deep. What would the casualties be if a meteor like that hit a city? Well, a popular display at the American Museum of Natural History in New York City, where they filmed the movie about Night at the Museum, it shows that if such an object were to hit Manhattan, that crowded borough would be completely destroyed. Another famous crater, known as Chicxulub, produced a scar on Earth's surface some 110 miles or 180 kilometers in diameter. It's located near the northern tip of Mexico's Yucatan Peninsula. This huge crater is believed to be the impact site of an asteroid that was 6 miles or 100 kilometers wide. Now, some claim that the climate change is triggered by the impact from this particular asteroid actually caused the extinction of the dinosaurs and a lot of other land and sea animals. But of course, there are some other theories as well. You decide for yourself. Now, meteorites have been found all over the world, and they vary in size and in composition, but the largest found meteorite is this monster named Hoba. It was given the name Hoba because it was discovered on a farm named Hoba West. It weighs 66 tons, and it's located in Namibia, Africa. Never been moved. And this is where it landed. To protect it from the estimated 100,000 meteoroids that are going to slam into it during its expected 20-year lifespan, the International Space Station is actually covered with a foot-thick blanket of Kevlar. Now, that's the material that they use to make bulletproof vests. They actually have a name for it. They call it the Whipple Shield. Each day, up to 4 billion meteoroids fall to Earth. But don't worry, most of them are very minuscule in size. Meteorite impacts have been blamed for hundreds of injuries, but only one has been verified by scientists. In 1954, Annie Hodges of Sicklacauga, Alabama, was struck by an 8-pound meteorite that crashed through her roof, bounced off her radio into her hip while she was taking a nap. Okay. So, not to worry about those meteoroids. As we continue our visit to the second floor, we're going to come across an exhibit involving our planet Earth. Now, scientists believe that the Earth formed about 4.6 billion years ago, and a lot of people tend to think that the Earth is a sphere, but science has actually come to understand the Earth is not quite a sphere. It's kind of like a flattened sphere. It's called an oblate spheroid. The name is similar to the shape is similar to a sphere, but where the poles are flattened a little bit and the equator kind of bulges or pooches out just a little bit. In the case of the Earth, this is due to our planet spinning around because of its rotation. Now, the structure of the Earth is divided into 4 major components. You got the crust, the mantle, the outer core, and the inner core. And each layer has got a unique chemical composition, physical state, and impacts life on Earth's surface. In fact, if you drilled a tunnel through the Earth and jumped in, which of course is not possible, but theoretically, it would take you about 50 minutes to fall to the other side. Okay. As I mentioned, that's not possible, but that's not to say that humans haven't tried. The Kola Super Deep Borehole is a scientific project that began in May of 1970 in an effort to drill a hole into the Earth's crust as deep as it could go. The drill site is actually located on the Kola Peninsula in Russia. Several boreholes were drilled there, with the deepest one reaching 40,230 feet. That's 12,262 meters. And this happened in 1989. Well, drilling stopped in 1990 because the temperature got too high at such a deep level for the drill bit to work properly. In fact, as they were trying to cut through the stone, it actually had the consistency of plastic. The Kola super deep borehole is estimated to have reached 1/3 of the way through what's called the Baltic continental crust and hit rocks that were thought to be over 2.5 billion years old. Now, the project was officially terminated in 1995 due to the dissolution of the Soviet Union. The site has since been abandoned. The only on-site evidence of the Kola super deep borehole today is the rusty metal cap that sits above the boreholes. Now, the Earth has two different types of crust. Crust that's underneath the oceans, we call that the oceanic crust. And then there's a crust that sits up on the land, we call that the continental crust. And the oceanic crust is a little more dense because it's made out of a substance called basalt. This weird looking Earth is actually a model of what are called plate tectonics. Now, Earth is the only planet in the solar system with plate tectonics. These plates are actually floating, as it's theorized, are floating on top of the magma interior of the Earth, and they react with other plates. You see, the theory of plate tectonics states that the Earth's lithosphere is constantly moving. The plates move apart, together, slide past each other. This was proposed by Alfred Wegener's continental drift in 1912. Of course, when he started talking about continents actually floating, he got laughed out of the building. But later, because of some scientific evidence taken in the Mid-Atlantic Ridge, it showed that perhaps he was right. So he was given credit for that theory. Now, what's interesting about this is that volcanoes and earthquakes occur at what are called plate boundaries. This is where plates are pushing into each other, sliding past each other, or pulling away from each other. You see, you have three different kinds of plate boundaries. You can have divergent plate boundaries. That's where they move away from each other. If plates are coming together, then you can have one of two things. If both of the plates coming together are continental plates, well, then you're going to have mountains. If one is a continental plate, one is an oceanic plate, we're going to have something called subduction. We'll talk more about that in just a minute. And if they're just simply sliding past each other and not hitting each other head on, we refer to that as a transform plate. Now, when plates are going to move apart from each other, they are said to be divergent. Okay? And when they do move away from each other, then magma, which is what you call lava while it's still underneath the ground, magma can come out and new rock can be formed. It's also called seafloor spreading if new seabed is made underneath the oceans. And the best example of underwater diverging boundaries or seafloor spreading is the Mid-Atlantic Ridge. And of course, the theory is that X and Y were touching at one point in time, but because those two plates, the plate where X is and the plate where Y is, are moving away from each other, then you have the sea floor actually spread. Okay? So the best example is the Mid-Atlantic Ridge. Now, sometimes we can actually see this above ground. Areas like the Great Rift Valley in Africa, the Red Sea between Africa and Southwest Asia. You actually see these big rifts are caused because of these plates moving. And the Mid-Atlantic Ridge actually comes above ground in Iceland. So the Mid-Atlantic Ridge is not all underneath the water. Okay. Now, when plates collide, different things can happen. Okay, so let's look at what are called convergent plates now. They come together. If they are of the same density and continental crust hits continental crust, then you're going to form the mountains like the Rocky Mountains and the Alps and the Himalayas. If you have one of those plates being oceanic crust and the other is continental crust, then you're going to see that one is going to slide down underneath the other one. Okay. All right. The Himalaya Mountains, as I mentioned, which includes, of course, Mount Everest, over 29,000 feet, or about 8,850 meters. Okay. This was actually made, according to the theory, by the Indian plate running into the Eurasian plate. They're both continental plates. They both have the same density. And so they pushed the plates up against each other, and that made the Himalaya Mountains. But most converging plates actually involve an oceanic plate, because the ocean, 70% of the Earth is covered by ocean. So there's a lot more oceanic and continental plate activity than there is the continental plates coming together. And this is where we get most of our volcanoes and our earthquakes, because as the denser oceanic slides down underneath the continental, there's not a bunch of grease down there making it slide easily. So it just kind of grabs and it pulls. And as it pulls down, the continental crust here, as this gets pulled down, it can actually cause cracks in here. And when these cracks form, that's where you get many of the volcanoes. And that movement can also, of course, cause earthquakes. So let's look a little bit more now about volcanoes. Let's watch a volcano video. Okay, as I explained earlier now, when two crusts with different densities collide, the more dense crust is going to go under the less dense crust. This puts a tremendous pressure on the less dense continental crust, and it can cause cracks that produce volcanoes. Volcanoes can also form at divergent boundaries, but these are almost always found down underneath the water, and we don't really see them. Somewhere around the world, there are likely about 20 active volcanoes erupting as I'm sharing this with you. Some are experiencing new activity, others are ongoing, but between 50 and 70 volcanoes erupted last year, and 160 were active in the last decade. Geologists estimate that 1,300 erupted in the last 10,000 years. Now, subduction is also responsible for what are called deep sea trenches. They see the Mariana Trench, sometimes called the Marianas Trench, because everything is about the Mariana Islands. So the Mariana Trench or Marianas Trench, it's found in the Western Pacific Ocean, not that far from Japan. It's the deepest part located in any ocean. It's a 1,580-mile crescent-shaped section of the crust of the Earth. And a very truly impressive part of the Mariana Trench has nothing to do with its length and everything to do with its depth. Although it hasn't been well explored because of the challenges associated with going down that deep, of course, the trench goes to at least 36,000 feet. It's deeper than the highest mountain is tall. So let's go with famous filmmaker James Cameron down to the deepest part of the Earth. Okay. All right, so movements of the plates can also form earthquakes. See what you know about earthquakes. We'll take our earthquake poll. Which of the following fact about earthquakes is not true? An entire city in Missouri was swallowed up by an earthquake. Millions of earthquakes happen every year. The place where an earthquake starts is called the epicenter, and Japan is the country where most earthquakes occur. So far, you guys have done a great job on these polls. This one maybe not quite as easy as the first couple. All right, let's end the polling here, and I'll share the results. And I gotcha. There actually was a city in Missouri, it's called New Madrid, that was swallowed by an earthquake. It happened on December 16th, 1811, occurred in the central Mississippi Valley. They felt it all the way to New York City. They felt it in Boston, Montreal, Canada, Washington, D.C. In fact, President James Madison, and his wife Dolly felt those earthquakes in the White House. Church bells rang in Boston. Okay. Now, the thing is, the area was so sparse and so few people that nobody was thought to actually have died. Millions of earthquakes do happen every year. In fact, the National Earthquake Information Center records an average of 20,000 earthquakes every year. That's about 50 earthquakes around the world. There are, however, millions of earthquakes estimated to occur every year that are just too weak to actually be recorded. The correct answer is the place where an earthquake starts is not called the epicenter. It's actually the hypocenter is where the earthquake starts. I know this is kind of picky, and the hypocenter is always going to be underground beneath the Earth's surface. Now, when you see that term epicenter, that is directly above the hypocenter. That's at the surface is where they mark it as the epicenter, but it actually started below. So the difference between them is that the hypocenter is underground, the epicenter is above ground. And that's where the earthquake actually starts. I know, okay, picky. And then finally, Japan is the country where most earthquakes occur. The most recorded earthquakes happen in Japan because Japan is within that Pacific Ring of Fire that was mentioned in the video. So it's actually on the edge of the Pacific Ocean, and the Pacific Plate is where you see so much activity. Okay. So let me remove the earthquake poll as we go to the seismograph. Now, earthquakes are formed when plates rubbing up against each other, they move. And there's a tremendous amount of built-up energy when they move. Scientists can use seismic waves to measure how big an earthquake is. They use a device called a seismograph that measures the size of the waves. The size of the waves is called the magnitude. Now, to tell the strength of an earthquake, scientists actually use a scale called the moment magnitude scale, or MMS. It used to be called the Richter scale. The larger the number on the MMS scale, the moment magnitude scale, the larger the earthquake. And each increase of 1 on the moment magnitude scale actually represents 10 times stronger. You usually won't even notice an earthquake unless it measures at least a 3 on the MMS scale. Now, it's estimated that there are some 500,000 detectable earthquakes in the world each year. 100,000 of them can be felt very, very strongly, and 100 of them actually cause damage. The largest recorded earthquake in the world was a magnitude 9.5 in Chile on May 22nd, 1960. And although they're both sea waves, a tsunami, literally from the Japanese for harbor wave, and tidal wave are two different things. A lot of people call a tsunami a tidal wave. They're two different things. You see, a tidal wave is a very, very shallow water wave that's caused by gravity between the sun, the moon, and the earth. But a tsunami is a sea wave caused by an underwater earthquake or a landslide that's usually triggered by an earthquake that actually displaces a tremendous amount of water out in the ocean. And the last type of interaction between tectonic plates is when they move past each other in a straight line. Now, this is called a transform fault or a transform boundary. And because of this slippage movement, transform faults can usually be identified by cracks that you see on the surface of the fault. The San Andreas Fault is transform fault in California. It's about 700 miles, 1,500 kilometers long, but it's not seen above the ground the entire way. Now, if those plates were to continue moving and sliding past each other, eventually San Francisco and Los Angeles would be crosstown baseball rivals again. And you got to be old to understand what I just said. Okay, I'll explain it to you. It's thought that eventually, if this were continue to happen, that San Francisco and Los Angeles would wind up next to each other. Well, San Francisco has a baseball team called the Giants. They used to be the New York Giants. And Los Angeles has a baseball team called the Dodgers. They used to be the Brooklyn Dodgers. So both teams at one time were in New York. So now they could wind up as crosstown rivals. But contrary to some beliefs, California is not going to fall off into the Pacific Ocean. It doesn't have anywhere to go. All right, the last stop on our journey of discovery of the Earth now is going to take us to something called a hot spot. In geology, a hot spot is where molten material from Earth's mantle actually reaches the crust. And one of the most famous hotspots in the world is the one that formed the Hawaiian Islands. A hotspot actually stays in the same place as the Pacific plate moves above it. Okay, so the Pacific plate is actually moving over this hotspot. When it breaks through the ocean floor, it creates a new island. You see Kauai up there in the top left corner? That was the original one. That's the first of the Hawaiian Islands. It's called the Garden Island now because it's had so much time to develop all of its plush foliage and such. Is actually where Jurassic Park was, #1 was filmed. And it used to be all the way to the right where Loihi is. Now you're thinking to yourself, wait a minute, I have been to Hawaii. They never said anything about Loihi. Well, yeah, you probably haven't heard of Loihi because it's still underwater, but it's currently forming. It's working its way up. Hotspots can also form under continental plates just as well. You see, that explains the hot water springs and those geysers like those that are found in Yellowstone National Park in the United States. Yellowstone actually sits on a continental hotspot. The heat from these hotspots warm up underground water, and that causes the famous geysers that are there. Now, here's some other hotspots found around the world. Maybe there's a hotspot somewhere close to where you happen to be. All right, we're now going to visit our last section of the Moon, Meteorites, and Solar System Gallery. Here again, we're going to see God's attribute of power. You see, God shows his power in the way that he created our solar system. We see God's pure power in the way that he created the many stars in our solar system. The scriptures talk about his creations. At Isaiah 40:26, it says, "Lift up your eyes to heaven and see. Who has created these things?" I'm talking about the stars now. "It's the one who brings out their army by number. He even calls them all by name. Because of his vast dynamic energy and his awe-inspiring power, not one of them is missing." Yes, the scriptures tell us that Jehovah God used his dynamic energy and his awe-inspiring power to create them. So let's explore this idea of energy a little bit more. To understand this now, we're going to go to the most famous equation in the world. You're familiar with it, E equals mc squared. And of course, who came up with that? Albert Einstein. So for our last poll, let's see what you know about Albert Einstein. Okay, and I'm looking for my Einstein poll. Here we go. Okay. And so, which of the following facts about Albert Einstein is not true? Einstein failed math as a child. He offered his wife his Nobel Prize as part of their divorce settlement. The FBI spied on him for decades, and Einstein's brain was actually stolen after his death. Which of those four is not true? This will be our final poll. Interesting stuff about Albert Einstein. All right. Almost there. We'll end the polling now, and I'll share the results with you. Aha. Well, let's just take them one at a time, shall we? Einstein did not fail math as a child, as is sometimes said. The records actually show he was an exceptional, although he was kind of stubborn, very reluctant student. He scored very, very high grades during his high school days in Munich, Germany, and got really frustrated by what he described as the mechanical discipline demanded by his teachers. In other words, having to do 100 multiplication problems every night. He did offer his wife his Nobel Prize as part of their divorce settlement. That's true. As part of the agreement, he promised her an annual stipend plus whatever money he might receive from the Nobel Prize. Of course, he hadn't won it at that time. He does win it, and he was confident that he would win a Nobel Prize. His wife, Merrick, agreed. Einstein later stayed true to his word. He handed over a small fortune when he did receive the award in 1922 for his work on the photoelectric effect. He was spied on for decades. You see, shortly before Hitler rose to power in 1933, he left Berlin for the United States. He took a position at the Institute for Advanced Study in Princeton, New Jersey. His support of pacifist, of civil rights, left-wing causes had already drawn suspicion from J. Edgar Hoover's FBI once he first got to America, and they kept on watching him for 22 years. Agents listened to his phone calls, they opened his mail, they rooted through his trash, all of that in hopes of finding something that would mark him as a subversive or a Soviet spy. They even investigated tips that he was building a death ray. And then finally, the last, Einstein's brain was stolen after he died. He died in April 1955 from an abdominal aortic aneurysm. Now, he had requested that his body be cremated, but in a bizarre incident, Princeton pathologist Thomas Harvey actually removed his famous brain during his autopsy and kept it in the hope of unlocking the secrets of his genius. Finally, they got a reluctant approval from Einstein's son, and then Harvey later had the brain cut into pieces and sent to various scientists for research. So now you know a little bit more about Albert Einstein, especially that equation. No doubt you're familiar with the equation, right? It's the most famous equation there is. But do you get it? Do you really understand what it means? Well, let's let the person behind it explain it to you.
It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is put equal to mass, multiplied with the square of the velocity of light showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Cockcroft and Walton in 1932 experimentally.
Okay, did you get that? That's interesting to actually hear his voice, huh? Okay, if you didn't, let me break it down for you. All right, E stands for energy. Now, energy is measured in a unit that we call a joule, Joule, not Jewel, a joule. It was named after James Joule. Okay, so that's why it's called a joule. M stands for mass, how much stuff something has, the mass of 1 kilogram. Okay, that's about 2.2 pounds. Now, C stands for the speed of light. Now, the speed of light is 3.0 times 10 to the 9th meters per second, or 186,282 miles per hour. That is an incredible number. In fact, that's like something going around the Earth 7.5 times in 1 second. That's how fast the speed of light is. It's a huge number. Now, as of right now, we're not sure exactly how he got that number. It's thought that in his processing, it just kind of popped out, the fact that he would have 3.0 times 10 to the 9 meters per second squared. If you actually do that and you square it, you get 9.0 times 10 to the 16th. So here, in essence, is the point, right? You have the amount of mass in something the amount of energy in something is equal to how much mass there is times this unbelievable number, 9 times 10 to the 16th, 16 zeros following it. So as Einstein said, the joules you produce are equal to how much stuff there is times this incredibly large number, which means you get an unbelievable amount of energy from a very, very, very small amount of mass. Okay, so remember we said we talked about the meteor. So how much energy there has to be able to convert all of that one little grain of sand into something that we see so far off and that can be so bright. It's absolutely amazing. So the thing in that formula to just keep in mind is that C squared, or 9 times 10 to the 16, is multiplied by how much mass you have, and that tells you how much energy in joules you have. Unbelievable amount, okay? So 1 calorie is equal to 4.18 joules. And if you do the math on it, okay, it didn't take a whole lot of material to produce the hydrogen bomb in Hiroshima. In fact, the core that exploded in the first atomic bomb there was only the size of a basketball. Now, it's guesstimated that the average person has enough matter in them that if they were to spontaneously be converted to energy, if all the mass in you were instantly turned into energy, it would be equal to about 16 atomic bombs, just like the one dropped on Hiroshima. So you have a lot more energy than you think. All right, tremendous amount of energy, right? Just like the scripture says. The Bible also describes how the earth was supported and its shape, talks about its shape too, many centuries before man actually verified that by science. Job 26:7, notice what it says, he stretches out the northern sky over empty space, suspending the earth upon nothing. You see, the earth is in outer space, and since it's a vacuum where it is, literally, it's suspended upon nothing. It's in a vacuum. And then there's Isaiah 40:22. It says, there is one who dwells above the circle of the earth, and its inhabitants are like grasshoppers. He's stretching out the heavens like a fine gauze, and he spreads them out like a tent to dwell in. Well, a couple of things here. The fact that the circle of the earth, and then like a fine gauze. Well, gauze is actually used in trying to explain Einstein's theory of relativity and time. They actually use that expression, gauze. So here you see this so many years in advance. So how do you suppose the Bible writers knew these things so many years before they were actually verified or anyone would know? Well, of course, the answer is obviously the scriptures were inspired by Jehovah God. Well, that's it. Hope you've enjoyed the second part of our tour from the Natural Museum of Natural History at the Smithsonian. We are going to finish our tour of the museum in part 3. But before we go, I invite you to lose yourself in the night sky and in the Milky Way galaxy.
It's estimated that as many as 80% of all the people on Earth today have never had the chance to witness a clear view of the Milky Way. In 1994, a major earthquake struck Los Angeles, causing massive power outages across the city. Residents reportedly called 911 to express alarm about a strange, silvery cloud hovering overhead. They were in fact seeing the Milky Way galaxy for the first time.
Jehovah's power, it's something, isn't it? Okay, well, thank you very much for attending or joining today. I'm going to, let's see, stop the share now. And at this point, we will go into our question and answer session. Again, I hope that you will be able to give me some feedback through the chat, share with me some thoughts that you might have. This is the first time I've done this tour, so any feedback would really be appreciated. Things that you think you might, you liked, things that you thought could be cut or could be adjusted. I always have people at this point ask about donations or a gift or leaving a little bit something. So let me just kind of get that out of the way if I can. Okay. Let's see this. There is a slide that I'm supposed to show. Yeah, here it is here. This is to help offset the costs. If somebody charged you for being here today, go get your money back because this was free. There is no charge for this. But if you'd like to leave a gift or something, it's appreciated. We do have some people that actually are paid to keep all this going through the My Virtual Bible Tour group. They tell me if you like the Zelle or the PayPal thing, then it's Jim at mybibletours with an S.com. If you're overseas, you're not in the US, they said sometimes this works better. Okay. You see the My Virtual Bible Tour. Note there is no S here. Okay. And then this is how you would do it with a credit card. And then down here at the bottom, if you want to actually go old school and write something, want to send a check, you can send it to My Virtual Bible Tour group in Stamford, Connecticut. That's where headquarters, for lack of a better term, is located. But please put Jim on the memo line so they'll know that that was intended to go to me. Okay. I'll leave this up for just a couple of seconds left, and then we can get to my favorite part, which is you. If you need a copy or need this information, you don't have it yet, please take a picture of it so that I can get this off the screen and get on to more interesting things. Okay. All right. Let's go ahead and stop share on that. And oh, look at all the hands. Great. Thank you so much. Again, I appreciate the thoughts. When I do the question and answer part here, I don't always get a chance to see what's in the chat. So if you have a question that you really, really need answered, please join the hands, raise your hand, whatever color it is. And then I'll get to them in order. I go from the very, very top and work it all the way down. Sometimes I see your comments on the chat. It's set up so you can only chat me. You can't chat everybody, just me. And sometimes I see it. I'm going to take these off. They're not my prescription. And so if you have a question that you really, really want to answer, I might not see it in the chat. So please go to the question. Raise your hand. That's what I meant to say. All right, let's start with Katie Holloway. Okay. You know what? I tell you what were the numbers? The numbers are at 480. I tell you what, Katie, before you get going, why don't you hang tight? I don't like talking to squares with names on them. I've been talking to the blank screen for the last hour and a half. I'm going to open this up so you can turn your camera on. Okay. So be forewarned that about to allow you to have your camera on. So if it's set so that it comes on, I don't want you to get surprised. Okay. So I have pushed the start video, and this will give us a chance to, yeah, there's the beautiful faces. Look at all those pretty people. I love this part. Look at you guys. Yeah, y'all clean up good. Very, very nice. Okay. All right, let's go to Katie Holloway. What is your question or your thought or your comment, dear?
Just so you know, I enjoyed your tour. I can just remember sitting in 5th grade, learning about the moon, the waning crescent.
Oh, do you remember it now?
Yes, sir.
Okay, what happens first, waxing or waning?
I think it's the waxing.
Yes, it's the waxing. Okay, wax on, wane off, right?
Yes, sir. And I'm trying to see, why did some people say that the moon was made of green cheese?
I'm sorry, what was the question again?
How come some people say that the moon is made of green cheese? Well,
because it's silly. And back a long time ago, back in the 1600s, it was said to show that some people just believe anything without any proof. And so sometimes that expression is used. And of course, it's kind of it's so ridiculously outrageous that it's kind of funny in a way. Did you like my joke though? Unless of course it's Munster cheese. Did you get that?
I didn't. I didn't
Okay.
I didn't get that.
There's a kind of cheese called Munster cheese. It's Meunster, I think is how it's spelled. I could be wrong, but I think that's right. And so that's pronounced Munster cheese. So unless, of course, it's Munster cheese.
Oh, okay.
Okay, I see you shaking your heads. Shame on you. That no refunds. So if you didn't like it, tough. All right, well, thank you for your comments, dear. Okay, let's go to Jason Fenwick.
Hi, it's actually his wife again.
Hi, Jason Fenwick's wife.
I enjoyed your tour as usual. If I was young enough to go to school at the time that you're teaching, I would definitely be happy to have you as a teacher.
Oh, it's all smoke and mirrors. Smoke and mirrors.
Is that what it is? Could you tell me a little about Mount Vesuvius? Anything that you can tell us about that? When that volcano erupted, and were the people surprised, or was it rumbling? Do you know before that? Or?
Well, you know, Vesuvius happened close to Pompeii and to Naples in Italy, and it's still active volcano.
Wow.
And so usually when a volcano goes, there are shocks. You usually do get some warning.
Mm-hmm.
But, you know, a lot of times you think how far back you go, they didn't realize what exactly that meant. You know, many of them back then worshiped different gods, and their thought was, well, this is just Zeus up in heaven being mad at his wife and making some noise. They didn't really realize exactly what it was until, you know, it happened at that time. But they were probably given some advance notice by some shaking before it blew. Like Mount St. Helens, they knew it was going to go.
Yeah.
Way before, and yet some people still stayed and they died, but they knew it was going to go.
Yeah, well, that was interesting that they were able to fill these fossils, or whatever do you call it, the things that were left over, and they could get the shape of the bodies and see the expressions on people's faces.
Right. The casts that are formed from those people getting covered up with that molten ash.
Wow.
Yeah, that is an interesting exhibit. If you ever do get a chance to see the Pompeii thing, it really, really is very interesting. Okay.
Oh, yes. Okay, I'll hang on for part one for next time.
All right, thank you. All right, let's see. Tyler Severin, that name looks familiar. Have you joined me before, Tyler?
Yes. Yes, several times actually.
Yeah, I was going to say that name looks familiar. How are you?
Pretty good, and you?
Good. I'm okay, as well as can be expected.
There's a comment I wanted to make that you mentioned about diamond being the hardest natural material. Interestingly, something that's kind of new, they found a mineral called hexagonal boron nitrate that comes from volcanoes, and it's supposed to be harder than a diamond.
Really?
By about 18%.
Okay, what's it called again?
Boron. It's hexagonal boron nitrate, and it's supposed to be extremely rare.
I will research that. Thank you very much. I appreciate that information. That's why I like doing this with an audience, because you can give me stuff to check. And I have had people before that have shared things, and I'm like, ooh, I got to change that. I need to adjust that. And then sometimes it's like, nah, I was right once I checked it out. But so I will do that.
And then there's supposed to be lonsdaleite, which is another one, but that's formed by meteorites.
Okay, so would you call that natural? Yeah, I guess the natural thing's got to come into play. But yeah, I'll look that up. I've not heard of that. Thank you very much for that info. Okay.
And if I could ask a couple of questions on his.
Yes. Wait a minute. Is there a ventriloquist?
Yeah, he doesn't move.
Oh, there you are. Oh, there's other people with you. Oh, I didn't realize Tyler had other people. Okay.
Yes. You had that illusion of light. Was that the video that you showed just before you went off? Is that?
Yeah, I got that off of YouTube.
Oh, okay. I like that.
I do
did
too.
You know? Yeah, in Death Valley, there's a place they have it blocked off now, but it's a hole where there's water, and if there's an earthquake in China, the water will splash in that hole.
Wow.
And they sent men down. They went down 600 feet, couldn't see anything. they sent a camera down, I think it was either 1,000 feet or something like that, and they couldn't see anything. But that was something really amazing.
Huh. Yeah, that is something to, I guess just hopefully they let China know. Yeah. Well, thank you very much for your comment. I appreciate that thought. I did that at the very end to kind of have a nice finishing send off to refocus attention to Jehovah and his creation and his power. Let's see, Becky.
First of all, this tour was absolutely amazing.
Oh, well,
it blew my mind away. And I was taking notes, by the way, because I could not remember all of it. So
me neither.
Yeah, and that cheese is actually spelled M-U-E-N-S-T-E-R. Munster cheese.
M-U-E-N-S-T-E-R.
Yeah, M-U-E-N.
And it's pronounced Munster?
I don't know.
Munster. Okay.
Yeah.
I think I said M-E-U, didn't I?
Yeah, and it's by German immigrants who I think introduced it.
Okay.
Yeah. So I just wanted to say thank you and amazing.
Well, that's very kind.
Don't change anything in this one. It's just amazing.
Okay.
Well, you could maybe add more to make it better, but yeah, that's it.
Well, I got a part 3 coming out. And thank you so very much. You don't know how much that means to me for you to say that, because I've spent an awful long time putting this together to be able to present it. And this is the first time it's been shown. I mean, we didn't even have our focus group look at it. They're recording it, by the way. That's why it might have said this is being recorded. I'm not recording it, they are. And so that way we can make sure that it's in line with the suggestions that we're getting from the branch on these Zoom tours, to make sure it's in compliance. I gotta say compliance, but it's aligned with what their suggestions are. And so the first time you do something, of course, it's like going to the comedy club. You can try out your act down at the local comedy club and see if the jokes are any good, and then you can keep them. Well, you guys are the guinea pigs. Thank you. You're not quite as fluffy and hairy as the last guinea pigs that I worked with, but you're still cute, and that's all that counts. So thank you very much for those kind words and sharing that with me. It's nice to know. I'm happy to hear that, but I do know that there is improvement to be found here. So please share with me bad jokes, bad puns. Thank you very much to Tyler for that information about that material. I want to continue to make it good. All right, let's go with Chandra.
Hi, Brother Jim. Thank you for the tour. My son has a quick question first.
Okay.
Do you do dinosaurs like in your part 1 or your future part 3?
Well, actually, I don't do it in part 1. I'm not sure if I'm going to do it in part 3 or not.
Oh, okay.
Because, and I'll tell you why. It's been done so much. And I know a lot of people think that dinosaurs are really interesting, but most of your science museums, when they originally started out, they were just a bunch of skeletons and a bunch of stuffed animals that were on display, and then a bunch of old bones and things that were found and so forth. So right now, it all depends upon how much time I fill with other stuff. If I come up short and I don't have an hour and a half worth of stuff for the tour, then I'll probably go to dinosaurs. It's controversial. There are a lot of questions about it that we can't answer from the Bible. And so we can't deny them, of course. We know they had to have been here. There's too much evidence for that. But it's not something that shows up that really displays Jehovah's cardinal attributes. If you've noticed along the way, I've talked about God's wisdom. I've talked about his power. I'll talk about his love in the next one a little bit more. Talk to his creative powers. Dinosaurs in themselves don't lend themselves directly to that. So we'll see, okay? Right now, I can't tell you for sure, but it's a great question. You like dinosaurs, huh? Yeah, what is your favorite dinosaur? I'm gonna let you unmute. What is your favorite dinosaur?
Probably the Spinosaurus because it looks like a crocodile.
Uh-huh.
Yeah.
Most people like the,
T-Rex.
the T-Rex there.
Yeah. Useless arms.
Gotcha. Yeah. There you go. Enough Jurassic Park already, right? Okay. Well, thank you very much for your question. All right. Let's see. Let's go to Raven. This is a name and it's familiar to me. I know.
Yeah, I'm just not showing my face right now because, like I told you last time, I've been having seizures. So when I get through with them, I'll show my face again. I just wanted to say thank you for starting it back. And I seen part 1, and now that I know you'll have a part 3, I'll see part 3 when it comes out. And I've re-registered for part 1, so I'll be seeing that on the 24th. And I'm glad that you started it back. And I had a question too. What was the question I was going to ask you about that? I just wanted to say that I was very glad that you did the jokes because it was very good of you to get all that stuff for your wife for the anniversary.
Yeah, she hadn't heard though. She was in the meeting. I don't know if she's still joined. I don't see her over here. Let's see. Yes, no, I don't know if she's still on or not, but she did watch from the other room. So I don't know exactly. Yeah, she's still on. She's listening right now.
All right. Well, say hi to her, and I will see you and her on the 24th, and then whenever you do the 3rd one.
Well, thank you. That's very sweet of you. It really, I really appreciate all the comments I get about my wife. I'm going to ask her, honey, why don't you come in here? So I can get you on camera. I just love it when people ask about her because she has been so supportive of me, especially during my recent health concerns. And so this is my beautiful partner, my wife.
It's good to see you again.
There she is. Yeah, see her? Yeah, she's gorgeous. I'm definitely married out of my pay grade. There's no questions about that. So it's just, I love it when so many people ask about her.
With your Texas hats on.
Oh, they're right here. They're within reach.
Yeah. She's got to have her hat. Yeah.
Is it? It doesn't show.
Yeah. You got to hit it. You got to hit it just right.
Remember, everything's bigger in Texas.
There you go. There you go. Spoken like a true Texan.
It's good to see you again, though, Jim.
Thank you, dear. Nice talking to you too. Thank you.
Thanks for coming.
Okay, let's see. Let's go with let's see, M&A Amato. Can't hear you. Can't hear. Can you unmute yourself? Need to push the button again. All right. Oh, I just muted you after you unmuted. Okay. Unmute yourself.
Here. Okay.
There you go. Now we can hear you.
My question has to do with these fake Star Wars movies and these outer space movies when they're making all this noise when they're shooting at each other. And I was watching a science program some years, maybe months ago, and I was so happy to hear that that's impossible. And I love telling everyone who loves Star Wars that you can't do that sound effects in outer space. Could you explain that?
Yes. Okay. In order for sound to work, you have to have air molecules hit your ear, and that causes vibrations inside of your ear, and you're called your eardrum, right? You're familiar with the eardrum, and that actually pushes and pounds on the 3 little bones in there, and they make little hairs inside of your middle of your ear, in the cochlea part of your ear. They make them jiggle, and that corresponds to your brain understanding what that particular sound is. But you have to have air molecules hit your ear. Well, guess what you don't have in space? There's no air in space. So sound waves are considered to be what are called mechanical waves, as opposed to light, which is an electromagnetic wave. It doesn't have to have a medium. So for sound to travel, it has to travel through a medium, just like a water wave. You have to have water as the medium in order for a wave, when you throw a rock and it makes the ripples, the medium is the water. You have to have something for the energy in that wave to travel through. The energy can't travel through space because there's nothing in space. So hopefully that explains why there's no sense in screaming, because they can't hear you. And no, they can't, you cannot hear the choo 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 noises in space, but you know, that of course is Hollywood. Okay, let's see, Sandra and Fred Mueller, or Muller. I guess that's Muller.
Yes, Jim, I wanted to ask you, since you're a science teacher, how long have you been a science teacher?
Way too long.
Okay, now.
Yeah, just ask my students, they'll tell you.
Okay, because you make science exciting, because when I was in science, sometimes when you have to look at the charts and the number that goes with each mineral, you know, it gets kind of confusing, but you make a good science. Now, did you have trouble when you had to go into the evolution theory and all that? Did you have trouble when you had a class with that?
Oh, no, I didn't, because I had a standard approach.
Okay.
And what I would always do is, in the state of Texas, you are required to teach the concept of evolution and evolutionary theory.
Okay.
So you can't get around it. You can't just not do it.
Okay.
There was a time when you just didn't have to do it, but now you do. So what I always do is I share with my students this thought, and I say, okay, we're going to talk about evolution now. First of all, I want to make sure that you understand that I am not going to challenge any of your personal religious beliefs, because I have very strong personal religious beliefs myself. So please don't feel like anything here is going to be forced down your throat. I've seen that happen before. I very much hate it. And so understand, in a science classroom, I am required by the state of Texas to teach you science's understanding. And this is only science's understanding. This is not to say it's the absolute truth. It's just the way science understands it. And science will not allow for the supernatural. You see, science has to be measured. You have to be able to measure something, collect data. You can't do that in this regard. So science doesn't allow for miracles. You can't have ghosts. You can't have any of that kind of stuff in science. But again, this is only science's explanation of it. Now, by law, I am not allowed to tell you what I personally believe unless you ask me. Unless you ask me.
Right. That's why
you ask me.
Right. That's why it's called the theory of evolution, not the law of evolution. There's a difference. Okay. Yeah. And also, I like that. I love your jokes, because you make it exciting and you make it fun, because a lot of times when I had to take math and science, it was serious, you know, and you had to take a test at the end and you hope you pass it, you know. And just like, for example, the question Tyler mentioned about the boron, you know, I never heard it. And the question I got for Tyler, maybe you can answer later, do they actually have a sample of that in the Institute that we can see what it looks like, where you can see a diamond, you can see an emerald, but I've never seen a piece of boron. Where can you see that? And also, I like the thing that you have with the dinosaurs smoking. What was the theory behind that? Because they died, my understanding, when a meteor hit and there was a weather change and they all froze to death or they burned up or whatever. Right. And the last question I have, does your wife get 50% of the credits?
she deserves 90%. So if she only gets 50%, she's being cheated.
Okay.
Okay, so let me answer that one first. The second one, yeah, there are a couple of theories about why so many dinosaurs went extinct in a short period of time. And one does have to do with an asteroid or meteor if you want to call it that, that hit in Mexico.
Right,
And
Yucatan.
because it blew up so much material, it kind of darkened, almost like a gigantic volcano.
Like a cold winter, right? And everything became dark.
Yeah, because of all the stuff that was up in the sky.
Right.
And so the sun couldn't go through, and there were plants that couldn't do photosynthesis, and they didn't have anything to eat, and so forth. And that thought along those lines. That's one possibility. But the cartoon there is from the far side, Gary Larson, where they're all smoking, and it says, "This is how dinosaurs really went."
I didn't want somebody to think they died of lung cancer.
Yeah. Well, that's.
But listen, if you get a chance to get Tyler back, I'd like to know the question about where can we see that a piece of that material that they say was harder than diamonds.
Okay, let's see. I do see that Tyler is still on the screen.
Yeah, I see him.
Can you, Tyler, can you raise your hand so I can unmute you? If you care to comment.
There he is.
Okay, let me unmute you there. So if you have a thought.
Yeah, yeah, they don't really have it. It's just basically like scientific because it's just so rare. They just don't really have it available for museums to even have because it's just so small.
Thank you.
Yeah, sure. Thanks, Tyler. Yeah, I'm not aware of it being at the museum. I mean, it was certainly not there when we visited. And I'm not aware. In fact, as you saw in my response to Tyler, I'm not even aware of it at all.
Right.
So I can answer nothing about it, but I assure you I will research it because that's interesting. I like cool stuff. I like interesting stuff. And all the tours that I give, whether it be the Misled by Artful Deceptions from the Louvre, the one I gave, or the Greek tours, I like interesting stuff. And I've always been under the impression that other people like interesting stuff too. Well, I've had to learn that's not true. Not everybody finds everything that I think is interesting. But for those people that got nothing better to do and want to listen, if you find something interesting, then that's what I want to include, because I've learned a lot of stuff over the years teaching science that I thought was pretty interesting to the average person. But where would they ever find out? Where would they ever learn it? Where would they know it? And so that's why, I share that with these tours, and they are specifically designed to be science first, Bible second. They're specifically designed that way. It's not taking a theme and then using science to prove that theme. This is some of the science out there. And oh, by the way, God already did it.
Well, Jim, I want to let you know you did a good job, and we appreciate your efforts in educating us.
Well, you're sure welcome. Thank you for joining us. I hope you would join us again.
We will.
Okay, thanks. All right, let's see, Sheila. Let's go to Sheila Couch, please. Can you unmute there? There you go.
Yeah, I really enjoyed it as well. I was absolutely hopeless at things like this at school, and I still am. But what I'm interested in is, there was a young brother used to be in our congregation with autism, and he is very clever at things like this. And we were on the ministry once. This was like before the lockdown and everything. And I says, oh, I made a mistake. I says, oh, look, there's a rainbow up there in the sky. And he says, well, actually, and he goes in all the chemistry and everything about the rainbow. My mind was puddled by the time we got out the car. But he would love this, Jim. So are you doing this one again? I must tell him.
Yes, if you go to my virtual Bible tour, I'll tell you what, I'm gonna put it in the chat. And I'm gonna send it to everyone here. All right. This is www.my.com. Okay. So in the chat, I just sent it to everybody. That's the website where you can sign up for the tours.
Okay.
I do part one, I do a part two.
What did you do in part one?
I'm sorry, we did the bottom floor where we do the ocean. I talk about whales and elephants and coral.
All right.
And animals and other cool stuff. So that's all on the first floor. And then this goes up to the second floor. And then I'll finish it up on the second floor here. And then maybe go down to the third floor, depending upon how much time I have left. But I do it, it's Greek to me, and it's still all Greek to me. The still all Greek to me will be this coming Saturday. That's where we're going to actually go to a lot of the Greek islands and look at stuff that's mentioned in the Bible and some stuff that's not mentioned in the Bible. I'll go to the Milos, where the Venus de Milo was found. We'll look at Samothrace, a bunch of islands where Paul went in his missionary tours. And so you can see some of the scriptures written, particularly in Corinthians, were specifically written because of the year and a half he spent in Corinth. That's a long time. So he got to know those people really well and got to know all about the stuff going on around. So that part of the tour will be all about that. The first part was just about Greek culture and about Greek history. So I split it up. It used to be one tour, but I was advised to split it in half and add a little to the front and a little bit to the back. So I have to do, that's my chore this week, is to finish up still all Greek to me.
I just love, although I'm hopeless at things like that, I just love anything to do with the sky and the heavens, and you know, that term lost in space.
Right.
When you're staring at the heavens and looking through telescopes, I just love anything like that. So
and I'm glad. Being a science teacher, I just try to hit what's at the museum. And so those are the things that are at the museum that are covered there, and then try to work from that and find as much interesting stuff, and then explain things that, you know, the average person might not know, but maybe they might find interesting. So thank you for those very kind words. I hope to see you again.
Yeah.
Okay. All right. Let's see. Janet McKenzie.
And hello.
Hi there.
How are you? Janet McKenzie from Waterbury, Connecticut. How is everybody?
Okay.
So I had my hand up like several hands ago.
Okay.
And I said, by the time you got to me, I'd have a question.
Okay.
I don't really have
and
one.
You haven't thought of one, huh? Okay. Well,
I wanted to say that I really appreciate the tours. I was on the first one that you gave, 101 part 1, and it's so interesting. And for the explanation with E equals MC squared, so exciting. I still don't know what it means, but it's okay. It's okay.
Okay. Now all you gotta know from that is that C squared is a huge number.
Yes. Yes.
And whatever the mass is, multiplied times that huge number gives you a huge amount of energy. That's the whole point.
Okay. A friend that was on with me would like to know, her name is Erica. She wants to know, how do you know what a meteorite is, or what makes it different from a regular rock?
Well, it's what it's made up of, because most of them are made up of a certain kind of materials and rocks and materials that you don't find all over the place on the planet, especially mixtures of iron and nickel. You don't see that in a lot of places. So a lot of it depends upon where it came from. Yeah. If it came from an asteroid, it might be made up of all different kind of things, because that means it broke off from something. And we know it's a meteorite if you see it up in the sky burning up. So a shooting star that's made it to the Earth, if it actually goes through, because it's going to get burnt some as it goes through, but if it actually makes it to the ground, then it's called a meteorite.
Yeah, and that's why they're so heavy and dense.
Oh yeah.
Like if you find it, they're so heavy because they have the iron mixed in them.
Usually the iron and nickel, or whatever that rock material is that might be in them, is very, very dense. Because you also have to remember, as it goes through with all that heat would also compress it. That heat would also make it more dense as it went through.
Yeah, very interesting, very appreciated. And I'm looking forward to see the Greek tour. And they showed, you know, like all the different ruins and stuff of, you know, like in Greece, the well, I can't even think of any of the names. Acropolis or something with a polis in there. But it has you know, like,
That's pretty cool. I'd love to find one.
oh, did I say something that was real?
Oh, I mean, I would love to find a meteorite.
Oh,
Yeah.
oh, yeah.
I'm sure you could
yeah.
buy them. I'm sure somebody's selling them, but they're way out of my price range.
Yeah, I think we had found one some years back and brought it to the school. But
Yeah, I don't think my wife would want that for an anniversary present though. So
what did you end up giving her after, you know, you got her the bookcase and you got her the nothing and
no, I got her magazine rack.
a magazine rack? Yeah, that's what it was.
Because she left all those magazines all over the place. I figured that's what she wanted. No,
You knew she needed that.
I can't remember. I think we struck a deal X number of years ago. It's like, okay, we don't need to buy each other stuff anymore, but I usually get her something. I bought her a piano not too long ago. So
Oh, that was good.
that's got to carry me. Yeah, that's going to carry me for a couple of years, I think.
Oh, good. Oh, good.
I say I think, but
Mm-hmm.
probably not.
Well, it was nice talking to you, and thank you again. And we'll be on 3. Do you know when it's going to be in production there?
No, it won't be till August. Yeah.
August. Okay.
Yeah.
And Greek is on now? Is Greek available now?
Yes. Yes. Go to myvirtualbibletour.com and you can sign up for the 2 Greek tours.
Okay, beautiful. Thank you very much.
You're
Awesome.
welcome. Thank you. Bye-bye. All right, my brother from Africa. I remember you from last week. How are you?
I'm fine. And you?
I'm doing okay. Thank you.
Okay. Thank you, Brother Jim, for the tour. It was very, very interesting. I loved it so much. I watched the first one and I told myself what the second one will look like, but I was very happy I was around to see it. It was very interesting. I love everything that is related to the to science, creation, and everything. So I'm looking for the third one.
Well, that's
and I wanted
very kind
to
of you.
thank you for the effort you make to produce all these things.
Well, you're so welcome, and thank you for the kind words.
Okay, I wanted to know a little bit about the title of the tower.
About the what now?
Smithsonian. Yeah, the title of the tower. The title.
The Creation 101?
Yeah, but first of all, I saw Smithsonian.
Yeah,
I don't know what it is. Yeah,
okay.
What is it about?
All right, the Smithsonian is a bunch of museums in the United States, located in the capital of the United States, Washington, D.C. And if you can Google it, but it was all of these buildings were named after John Smithson, who was a British scientist who donated it all. And so Smithsonian has a bunch of different museums. You have the Air and Space Museum. You have the African American Museum now. You have history museums, a museum of American history. You know, that's where they have the little slippers from the Wizard of Oz, little the ruby slippers. They have those there and a bunch of stuff. It's American history. So it's a bunch of different museums, and the zoo in Washington, D.C., where they have the pandas. There's very few people get pandas if you're not in China. And so they have pandas, and so they're all there. So that's all part of the Smithsonian. So this is the National Museum of Natural History. Natural history is just a fancy way of saying science.
Okay, good. Thank you so much.
Oh, you're welcome.
Blessings to you and your wife.
Okay, thank you. Take care.
Yeah. Yeah. Okay. Bye to all.
Bye-bye.
Yeah.
All right, let's see. All right, I see that Tyler's, well, are you still with, yeah, Tyler's got a question. I'm going to let Tyler jump ship here real quick, or jump line. Tyler, you want to unmute in case there's a question
But
time?
this is Tyler's mom again.
Okay.
With regard to meteorites, you could go to the USGS website, and it says, "I think I found a meteorite. How can I tell for sure?"
Okay.
So it gives several factors, and we've had fun with this one.
Oh, great. Okay,
And
thank you.
also, Oregon University has a department that is devoted to the study of meteorites.
Okay.
They call them meteorites or meteorons.
Okay. Meteorites and meteorons. Yeah. Yeah, there's just so much information out there. I tell you, it's amazing, especially what's available on the net and different places. Okay, let's see, Monique Levitt.
Yeah, hi.
Hi.
Hi, how are you? So my question simply is, and I do appreciate your tours, I've done several of them, but I want to know more about the epicenter because that was new to me. You know, when we look at the news and look at the Weather Channel, if we see an earthquake, it always focuses attention on the epicenter.
Yeah,
So I got that question wrong in the poll, but in any case.
Well, okay, and this could be something that I change, that I adjust to, because as I'm doing this poll on the earthquake poll, if you see my tours, I like the which of the following is not a lot, because that makes one event discrepant. And it's a picky kind of a thing, but you hear a lot about people saying, well, the epicenter was here. The epicenter would be a location on the ground. It would be like the epicenter was in Fresno, California. Okay, but the earthquake actually didn't happen at the top in Fresno. It happened way down below. And so technically it's the hypocenter. So the hypocenter is directly below the epicenter, because epi actually means on top of, right?
Right.
Like epidermis, you know, your top layer of skin. So epi means on top of. So it doesn't really make sense, epicenter, you know, just in terms of on top of the center. So if epicenter means on top of the center's got to be below it, right?
Right.
So technically it's the hypocenter. But I was looking for something to try to get the distractor, you know, the wrong answer, so that I could explain the other ones. And I thought, well, this is kind of picky, yeah, but the other one's kind of hard to say. Well, okay, it's not Japan, it's you know, Hawaii or something. But I'll go back and relook at that. So thank you thank you for asking clarification. That makes me wonder if I shouldn't kind of readjust the poll.
Thank you.
Is that okay? All right, well, thank you so much. Let's see, Dale Busher, the Bushers there. Okay, please hang tight, guys. I'm clicking these in order on my screen from who clicked in or who raised their hand. So please be patient. I've got this afternoon set aside and I will get to you. Okay, can you unmute? Yeah, there you go.
Hi, it's Dale's wife, Deborah, that has a couple of questions. You told how to contribute, but you said it so fast I couldn't get it down.
Okay, I'm sorry. I missed that first part. Could you repeat it?
You mentioned how we could contribute to you.
Oh, okay.
But you said it too fast for me to write down.
Oh, okay. Let me put it up on the screen again real quick.
Okay, thank you.
Sure.
And one other thing,
Can you see it now?
No. Oh, it's yeah, but your picture is covering a little of it.
Do this right here.
Yeah.
Oh, okay. Here, you do that and I'll ask the question.
Could you be so kind as to take a picture of it?
Yeah, I don't have a thing. My computer would be the one, and you're
okay. Well, then I'll give you a second to copy it down. I just won't be able to look at you. So go ahead.
Oh, well, my husband's writing it down.
Okay.
You know, and I suppose you can't mention Jehovah's name, or you can't mention the God effect or anything like that.
We can to a limited degree. Yeah, and the directions that we got, they're a little bit vague, because our organization, and I assume you're a witness,
Mhm.
our organization is not dictatorial. And just like with the COVID vaccine, you know,
Mhm.
we're not being given directive ultimatums. We're not being told, thou shalt not.
Mhm.
And so we were given some directives, and in our interpretation of those directives, one of the key ones was not establishing a Jehovah's Witness ID.
Yeah.
And
Yeah.
so if you say Jehovah 500 times, then people that maybe aren't witnesses might make that connection. But
Yeah.
but we're still trying to work through that. We're still trying to see, and that's why they're recording this, because afterwards we'll get together and discuss, well, was this okay? Did that cross the line? Could this
Yeah.
be? Because it's odd for me to see God's power and not Jehovah's power.
Yes, right.
Are we good with the screen now? Can I?
Yeah,
He's got it.
You got what you
Well,
need?
you know,
Okay. Yeah, I'd much rather look at you than that.
oh, or one of the other cubes. Well, we really thank you for this. It's very refreshing to have Jehovah's viewpoint. We've been to some of the larger museums, Chicago and different places.
Sure.
And of course, that's never mentioned. And so it's very refreshing. And the fact that you have everything so well researched is great. And thank you.
Well, if you're saying stuff that's not true, then you know, you shouldn't be doing it.
No,
Yeah.
but it happens in the world all the time.
That's true. And if I do come across something that's not quite right, I will be so quick to change it. That's why I'm looking forward to researching this thing that Tyler sent, because I mean, if it all pans out, I will add it. I won't just throw all the diamond stuff out. I'll just reword, and then I'll mention it, because, oh, there's something now that's out there that, because 99.9% of the people watching it haven't heard of it either.
Oh.
That's my guess. I could be wrong on that, but that would be my assumption. And so they would find that interesting as well, because when he said there's something harder, I'm like, whoa, my ears perked up.
Yeah.
Now, are you an educator in schools or college?
Well, I've taught at Texas A&M University for a while, but I'm currently teaching at high school in Houston, Texas, because they pay so much better.
Well, that's always a draw.
Yeah, and when you've taught long enough and you've moved up the ladder and you've got enough years, you actually get to a point where they're paying you much more than you're worth. So I'm going to keep milking the citizens of Texas until somebody gets wise to me and says, why are we paying this guy?
We'll keep the secret.
This year I'll teach physics. I'll teach physics.
Oh, will you?
Yeah, I have taught almost every science except for astronomy. I've never taught astronomy, but I've taught all the other sciences. I've taught chemistry.
Yeah.
I taught AP or college level biology, college level ecology, AP ecology. I taught all those things for years.
Wow, that's great. But it's better that you're putting what you learned from Jehovah at the top of the list.
Oh yeah, the rest is poop. I mean, it's, you know, if it's not from Jehovah, it's worthless.
Right.
Okay, I'm paraphrasing the Apostle Paul. Let's just put it that way. I don't think he used that exact term, but you get the idea.
Yeah.
Okay. Well, thank you so much for your comments.
And thank you for providing this. It's very, very enjoyable and enlightening as well.
Oh, you're welcome. I hope to see you again.
Yep. And you got the donation. Okay, great. Thank you.
Okay, sure. Bye-bye.
Have a good day. Bye.
Thank you. Okay, let's see. Renee, right? Finally got to you. There you are.
Thank you. I really enjoyed the tour. I missed some of it, so I have to come back and see it again.
Okay.
But you You were talking about the earthquakes, and I know it's well known in California, but New York had like 2 earthquakes, and I was wondering where did how they say how it began? Did it begin in New York or someplace else?
Well, you do have some earthquakes that are not at plate boundaries. It's not the norm, but it does happen because of so much weight and the fact that everything on the continental plate is not just solid and consistent. You have water in between in different places. You have different densities of material. And since the other plates are moving and they're getting nudged, they get nudged in different ways. Now, one of the things that I find really interesting is the great increase in the number of earthquakes in Texas and in Oklahoma now.
Oh, wow.
And that's because of fracking. That's because of the technique where they actually inject material down into the shale underneath what used to be the easy oil, all the liquid crude that was just kind of hanging out on top. Now, to get it back out, they have to crack through some layers. And to do that, they do something called fracking. Well, what that's doing is it's putting this lubricant into the rock, and it's making the rock slide on the rock. And that's making earthquakes. So you have so many earthquakes now in Oklahoma because of the fracking.
Oh, okay.
So you're going to get them in certain places like New Madrid there, on the Mississippi River there in Missouri. You don't expect earthquakes there, but you do still get them on the continental plates just a little bit. But your big earthquakes are usually on the margins. They're usually where the 2 plates are together, because like in California, they're trying to slide past each other. Transfer. Just think all the friction. It builds up and it builds up and it builds up and it builds up and it builds up, and then finally it breaks and everything shakes like crazy. Like that's what you see in California.
Is New York expecting a big one, or is it going to just be little small ones?
You don't get many earthquakes in New York. They're known for other horrible things like rats and they got their own share of problems. I don't think we've thrown earthquakes at them yet.
Okay.
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 Thank you.
Thank you.
Oh, you're welcome. Thanks for being patient. All right, let's see, Natasha. Hi there.
Hi, brother. Thank you very much for it is mind-blowing when you are not used to hearing these things for many years. But it's wonderful at the same time. And obviously thank you to your wife, our dear sister. She's obviously a massive support to you, as you mentioned. So it's really good teamwork there. I had a question about, I didn't know whether I misheard you. Where you said that the shooting star we see is the size of a grain.
Yes, isn't that amazing? The average shooting star that you see is no bigger than a grain of sand.
So what makes it
so
visible to us?
You see all the energy that goes into it to make matter. And so all of that energy had to go into it. Well, that's why the E = mc square equation, because the mass is very small, but the c square is so big that you still get a whole bunch of E.
I think that's
it's just amazing when it talks about Jehovah's power. Jehovah's power is just, just mind-boggling, the power out there of all of this material, all this energy, compared to what we see as as a lot of energy in our mind. Nothing.
And I think also originally coming from South Africa, we saw a lot of clear skies. So I've been able to see, I live in England now, so I don't see as many stars. But it's just, I've never known that about the shooting stars. It's mind-blowing. Thank you very much.
Well, you're welcome. And thank you for the kind words. Okay, let's see. Charisse? Morgan? Charisse, can you unmute? There you are.
Yes, just a moment. Hi, fellow educator. How you doing?
I'm okay. I'm a little scared with educator. Okay.
Yeah, I was doing some spring/summer cleaning while I was waiting. So that's why you hear all this background.
Okay.
So with all your knowledge
I know nothing. No, the more you know, the more you know. You know nothing.
Are you guys pioneers?
Am I a regular pioneer?
Yes.
Well, I'm not sure. I'm not sure I'm at liberty to answer that.
Okay, because I would just love to have the opportunity, if not here on the new system, to hear your format, how you explain the Bible to those in the field or those who are going to be resurrected. So let's put that on the calendar for the future.
Okay.
Okay.
Yeah,
Okay,
I don't know
now-
when they say about our spiritual identity, I don't know if that includes after the, in this chat session or just during the tour. Let's just assume at this one point that it's during the tour.
Okay.
My wife is a regular pioneer. I'm an elder.
Awesome. I knew you was putting that brain to use for Jehovah. I knew it. It's awesome. Okay, so I have a joke for you. And I'm from New Jersey, Rose Hill Park congregation.
Oh, I'm sorry.
And you know what? I'm originally from California, Earthquake City. I just been here for 10 years.
Okay.
So, and I'm still sorry. This joke is not mine. It's actually Brother Hurd. And I tell you why. Brother Hurd was our circuit overseer here in
nice.
Jersey at our in our congregation. But because of this week, the midweek meeting, learning about our history, it being refined, the shepherds and blah, blah, I decided to do some research on each of the given bodies' real life story to get to know them personally.
Sure.
So the first one I started with was Brother Hurd.
Right. Well,
So
he is the oldest, so sure.
I'm gonna tell him you said that.
Yeah, you better research him while you can, because unless you're anointed, you ain't seeing him again.
Before he go up and do his duty. So in the research, he said that his wife Gloria, he said he always deemed her as a jewel. He said, so he used to tell her, "You're my hope diamond." Just what you brought out in the tour.
Yep.
So he says,
diamond,
here's the joke.
Yeah.
Yes. So here's the joke. He says, but I don't have to hope no more because I married her.
Okay. 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 Got it. I don't have to hope no more.
You can say what you want about Brother Hurd.
So I'm not going to say anything about Brother Hurd or anything. Certainly nothing negative. No, I think.
I thought it was one of those.
We probably read the same joke books.
And that's why I shared it, because you guys sound similar. It was like one of those. You got it. So I was like, he'll appreciate that. Jim would appreciate that.
I do appreciate it. Not sure I can fit it in without the backstory, but I appreciate it. Thank you for that real life experience.
Well, you know what they say, Jim. All society information booklets is you can't do because it's copyright. So I think that goes along with Brother Hurd's joke. It's copyright. You cannot do it.
All right, if you say so. There we go. So duly noted. It was duly noted.
And thank you for your wonderful tour. I'm a special education, in special education.
Okay.
And you know, it happens good days is bad, but hearing you, it would be all good days. So thank you for your contribution to secular education, and you as a servant with Jehovah, you and your own hope diamond wife as well.
Aren't you sweet? Aren't you sweet? No, I'm still a diamond in the rough, I think. Very rough, very rough.
That's all right. But the end result is beautiful. Thanks again, Jim.
Okay, you're welcome. Bye-bye. All right, let's see, Meshach.
Thank you so much, Jim. I really enjoyed the the talk. My wife and I from South Africa, Cape Town.
Okay, I've lost the audio. I can't hear.
I'm saying that I'm from Cape Town, South Africa.
Okay.
Can you hear me now?
Yes.
Yeah. Oh, that's good. We really enjoyed the presentation. We love the post, the way you brought in the post and how you brought in the videos to add to the narration, which really reinforced the message, and it really helped us to appreciate the information so well. Thank you so much. I have two questions. The first one has to do with the high priest garment. Of the precious stones that were used, diamond was not included, as you rightly mentioned. The question is, what was the reason why diamond was not included, given the fact that as at that time diamond was known? What could have been the reason? Is it because it was too difficult to cut?
It might not have been included because it wasn't that pretty. It wasn't that outstanding. Because when you find a diamond in the rough, it's just like quartz. It's like calcite. I mean, it's just a clear, looks like a big piece of glass, but it's not shiny. It's just kind of a foggy piece of glass. And so the other rocks that you see, the other minerals and such that were in the breast piece, they were pretty because they were polished. So they could polish them and they could smooth the edges off and make them nice and round and pretty and polished. But you can't do that with diamonds, because the only thing that can polish a diamond is either a diamond or this new stuff that Tyler told us about. The only thing that you can polish a diamond with, it's got to be harder than the material to polish it. So it wouldn't be that, it wouldn't stand out as being that pretty or that ornate. Does that make sense? The others were colorful.
The reason why it's I find it's strange to me that it was not included, given the fact that Jehovah was the one that gave them the prescription of what they need to do. And if you look at, for instance, the way the ark was built, the tabernacle was built, some of the acacia wood that was used was such a fine wood, and it has to be masterfully crafted in a way that was unique. And the people who did it were not skilled. So I was just thinking, probably, I was just wondering that diamond was not, Jehovah did not guide them to do it in a way that.
Meshach, let me ask you this. Why do you think diamonds are so valuable now?
Yeah, I could imagine that because it's now well polished. Is the cutting and the
they're beautiful, right? They're shiny and they got all the colors, and well, you don't have that back then. Okay. So our view of why something is beautiful and wonderful now is different than what it used to be, because somebody figured out, well, if I cut this little piece off here and I cut this little piece off here, light comes through and light comes back out, and it's shiny and it twinkles and wow. But they didn't have that back then.
Okay. Thank you.
What's your second question?
The second question, so if you look at what you described in terms of the plate tectonic and the drifting of the continents apart, it would appear there was a time when all of them are together. They were like more before they started drifting apart.
Yes.
Now, my question, if I look at the history of man from Bible point of view, humans have been here on earth for just about 6,000, a little more than 6,000 years.
Right.
Now, if we look at that history and we recognize the fact that humans were in America, so the Native America, in Canada, South America, they were natives before the whole exploration took place, and then they discovered those lands. But when they discovered that, they met people. My question: how do those people migrated across the vast ocean? Is it because the continents were closer in more recent years?
Yeah.
That the drift only occurred recently, that maybe it was close so people could cross?
Yeah. The general consensus is they crossed over a land bridge between what's now Russia and Alaska, and that it was not completely underwater at that time. that they may have walked across it. Here's the thing, so much of these guesses as to how old things are with humans are based on carbon-14 or radioactive dating.
Yeah.
Now, science itself will admit it's not 100% accurate. They're not willing to admit it's really, really off. But here's the thing, and this, hopefully you can follow, I can say this in a way that's easy to understand.
No,
okay, carbon comes in two major flavors. You have what's called carbon-12 and carbon-14. Now it's called carbon-12 because the nucleus has 6 protons and it has 6 neutrons. So 6 plus 6 is 12. Okay. Carbon-14 has 6 protons and 8 neutrons. Okay. But those 2 neutrons eventually break away and they change from 14 to 12. And that's what radioactivity is that parts of the nucleus break out and you have a change in the basic function of the atom. So carbon-14 becomes carbon-12. And everything is based on how much carbon-14 there is in something. Because if you have a whole bunch of carbon-14 in it, that means it's still pretty young because it hasn't had time to change to carbon-12. Are you with me so far? Okay. Yep. All right. Carbon-14 actually comes from nitrogen-14. And right now, to make carbon-14, you have to have nitrogen, and nitrogen gets hit by cosmic rays, high levels of radioactivity that change nitrogen-14 to carbon-14. And it does that by changing one of the neutrons, or 2 of the neutrons actually, that changes them, the protons, into a neutron, because nitrogen's atomic number is 7. So it's going to have 7 protons, okay, and it's going to have 7 neutrons in its neutral state. So those neutrons actually get those protons actually get changed into neutrons, and so that changes it from 7 protons to 6 protons, and that changes it to carbon. So long story short, to get carbon-14, you have to start with nitrogen-14, and you have to have all of this radioactivity, all this stuff from the sun, and all these cosmic rays and gamma rays and all this high energy. Okay, now stop and think about it. If you have a canopy around the Earth, how is that energy going to hit that nitrogen-14 to turn it into carbon-14? It's not. So they don't take into consideration the canopy, and that the amount of carbon-14 you currently have now is always going to be small because you didn't have a whole bunch of carbon-14 way back when the canopy was there. So all the carbon-14 that started after the flood, after the canopy dropped, all that carbon-14 has now had a chance to start breaking into carbon-12, but there wasn't that much of it to start with. So if I look at an object and I go, there's not much carbon-14 in here, this must be really, really old. Well, is it really, really old because my carbon-14 has changed to carbon-12, or there just wasn't much carbon-14 to start with? So do you see how you can get these variances in these 10,000 years and 15,000 years and 25,000? That's just science is guessing. But the canopy comes into play big time when you actually look at the actual dates. But they won't recognize the canopy because that's the Bible. There's no scientific evidence of the canopy because it's gone.
It's true. And they would not want to agree that man was created, which you put the starting of man for about 6,000 years ago.
And I'll tell you what I have learned too in my old age. It don't matter. It don't matter. one of Satan's biggest tools is getting people to think they have to know everything. They have to have a concrete answer to everything. If they don't understand one piece of it, all the rest of it's wrong. I can't accept everything if I don't understand every little tidbit, every little piece of it. And that's what Satan wants us to do. He wants us to go, but what about, well, stop. But what about all the other stuff that's true? You take 99% of stuff that you know is true, you can understand it. You take 1% you don't understand, and you're going to throw the 99% out because you don't understand the one. That's where humility comes in, to where it's like, it don't matter. Who cares? We're going to find out at some point in time. We're going to know, oh, wait a minute. Okay, no, they actually were here 20,000. Or we're going to figure out, we're going to find out exactly why all of that was wrong and we were wrong to start with. So we were right to start with. So that stuff like that doesn't matter. Never get hung up on some little scientific piece of minutia because they can't prove something. That's pride. Okay, I have to understand it. I have to understand it. No, you don't. That's what faith is.
Thank you. I fully agree with that. It's not everything we can understand now.
Right.
It's definitely, it's not
and if
possible.
you can't understand it now, man, it ain't worth understanding. Don't worry about it.
Absolutely. Thank you so much. I really appreciate everything, the answers and the
you are
questions.
welcome. And thank you for joining us. Bye-bye.
Bye.
Bye. All right, let's see. Karen Lang.
There we go.
Hi there.
Hi. Howdy. Howdy.
Howdy.
Well, I don't know if I should ask that after what you just said. Well, should I ask this question?
Well, please.
But this tour has opened up in my mind, in my closet up there, something that I had watched. It's been quite a few years ago, but it stuck in my head because I thought, how neat. I want to be alive in 1,000 years to see this mountain come out of the water, be alive to see that, because it was talking about that. Now, can mountains, I don't want to say the word grow, but you know what I mean? It just,
I'm sorry, to see the what come out of the water?
Mountain, like a mountain come out of the water.
Oh, okay. Why do you think the mountains are going to come out of the water?
Well, if there's water that goes down, then that's what I assume. The water level would go down and pop it out. But this here that's what I'm asking. Can mountains in the water, okay, they come out, there's volcanoes and everything like that. Now down in the ocean, can mountains build? Grow is the word, I guess I can say. Just keep piling and building and keep growing.
That's what Hawaii is.
That's where I watched it. It was talking about Hawaii, and it said that this mountain they showed was that it would take like 1,000 years, is what they said, if I remember right, to pop out, to come up.
Right.
And I thought, hey, to be alive in 1,000 years to see that.
Oh, okay. I understand. I'm with you now. I understand what you're saying. I said the mountain come up out of, yeah. I'm not sure when it's projected, like a Loihi, when they actually expect it to pop out of the water. I don't know that, but yes, I understand what you're saying now. Okay. I'm sorry. I'm a little slow.
Well, yeah, that's, all these questions, how you can answer them all. But I just, that this tour just brought it up in my head, and I haven't forgotten that, because that's kind of like a goal to see that.
Sure. Well,
take a trip and see it.
I have not read anything that said it was going to stop at Armageddon.
Yeah.
So you just got to make it into the new system, and and move. If that's the plan for you to move, if you're allowed.
Yeah. Well, I don't know. I'll probably change my mind then.
Yeah. Okay. I'm not going there.
Yeah, it's like, hey, there's other stuff to see, but maybe, I don't know. But anyway, I just wondered about that. I wanted to make sure I got that little.
You got that right. I got you. You're absolutely right. Thank you.
Well, I enjoyed it as always. And I like what makes it nice too. It's your delivery. That's what makes these jokes so funny, too, is how you do it. Because so anyway, that's, keep them all in there and everything. No matter what you do, it's great. And
and
I enjoy it. Yeah. And I sure enjoyed seeing all those gems. Ooh,
yeah.
Boy, that's, when you go in a museum and see them, and it's hard to break away.
They are beautiful, aren't they? They are just absolutely beautiful. Jehovah's creations are just amazing. Absolutely amazing.
Yeah. So, okay, I'll let you go on to somebody else.
Okay.
See you again.
You. Take care.
Bye.
Bye. All right, let's see. Let's go to 2 browns. 2 browns are better than 1 brown. That's what I've always said.
The question I wanted to ask you was the fact that I like your explanation on the shifting of the Earth plates.
I'm sorry. I all I heard was Earth's crust. What?
How interesting that was that you explained it.
Oh.
The Earth plates. The question I wanted to ask you was, does man play a important role in the Earth plates being shifted based on his testing in the North America, Nevada, and in the Pacific, putting pressure on these plates and how they are shifted? And would you say he's a great cause of that?
The cause of the plates to move?
Yeah.
Okay, it's because the theory is, and of course this is all theory. The theory is of plate tectonics is that you have what are called convection currents way down inside of the mantle above the core. Now the core, you got to imagine, is made of mostly nickel and iron, incredibly hot because of all of the pressure, all of the weight, and the radioactivity that's taking place down there. So it's like a little atomic explosions, nuclear fusion happening all the time down there. And so it's incredibly hot. So the thought is the magma, when it gets close to the core, gets really, really, really hot. Now, what does something do when it gets really, really, really hot and it can move? Does it go up or down? Think about a hot air balloon.
It's going up.
All right, it goes up, right? Because the heat makes it spread out and it becomes less dense. So it's going to rise. Now, as it goes up and it hits toward the surface, it's going to cool down. And what happens when something cools down? It starts to come back together, gets more dense, and then it sinks. If you've ever watched rice boil before, you ever notice how it goes up and comes back down and goes back up and comes back down and goes back up and comes back down? That's because when it's down by the fire, it gets real hot, it spreads out, it gets less dense, it rises. When it gets up away from the heat, it cools off, gets more dense, and sinks back again. Those are called convection currents. And it's thought that the magma is doing all of these convection currents going up and down and up and down. Well, if it's going up and down to the right on this one, it's going up and down to the left under that one, those two will split apart. If the convection currents are going up, and then they're kind of coming together, well, then the 2 plates above them are going to pull together. So it all depends upon the direction the convection currents are going. That's the theory.
Would you say that man is the cause of the heat on these plates based on his testing?
Do I think that who?
Man.
Oh, no, man has no say in all that, because that's all down in the middle of the earth.
Okay.
No, humans are not affecting that at all, in my opinion. I mean, I don't see how they could.
Yeah, but he's putting
climate, yeah, definitely affecting climate.
All right.
But no, not that.
Okay. So he's not contributing to
not to plate tectonics. No, man is not, because it's happening incredibly slow. I mean, it happens like 1.5 inches a year. I mean, it's incredibly slow. So how are you going to speed that up? Oh, thank you, Ben. How are you going to speed that up? I mean, 1.5 inches a year? Okay, 1 3/4 inches a year. Boy, we really sped that up. I mean, no, man's not going to be able to contribute to that. But that's a great question. I love it when I have to think myself. So thank you.
Okay.
Okay, take care now.
All right.
All right, let's see. Let's go to Indira. Can you unmute yourself there, Indira? There you are. Hi.
Hi.
Okay, now I can see you too.
Hi.
Hey there. You in the red shirt. Hey there.
I had several questions. First of all, we just really did love the very ending of your presentation. The whole thing was just wonderful. Actually,
thank you.
Yes, the ending of the presentation was really wonderful with the Milky Way galaxy. But I just personally wanted a bit more of the wow factor of the Milky Way, the scene itself of the Milky Way. It was not as pronounced as I was hoping it would be, just simply because I don't ever get a real good chance. We love to look at nature programs, but to actually see a real expression of what the Milky Way looks like in its totality,
right,
at nighttime.
Where do you live?
Oh, I'm sorry. We live in Alabama.
Okay, so
we do get a chance to see the sky.
Yeah, you can. Yeah, even in the rural, because of humidity and cloud coverage and such, you're not going to get. We went to the bottom of the Grand Canyon.
Wow.
And at the bottom of the Grand Canyon, there's basically no light. And I have never seen so many stars, and amazing. So you get out into the desert away from everything, and you see stars like you would not believe.
See. Wow. Well, we will have to take a trip out there one day.
Maybe one day you'll see it out in the desert, and it will be like, wow.
Wow. After the pandemic is over. Sure. Or if not, just wait till paradise. That's fine.
There you go. There you go. You got time.
Yes.
It's not going anywhere.
That's right. Okay. Getting to my real question though, in the very beginning, it was just fantastic. Personally, I just love gems of all sorts. Diamonds and pearls are my absolute best. They're the top of the list. I just don't seem to be able to get enough of them.
So diamonds really are a girl's best friend? I've heard that.
In my case, it's true. Yes. Okay. However, I was wondering if you had more of samples of some of the varieties of the gems that are on the earth, and especially those samples that are mentioned in the Bible. Such as onyx or jasper, or I don't remember seeing those, or topaz. Maybe you showed topaz, but I don't remember seeing topaz.
Topaz is in the breast piece, I believe.
Yes, okay.
Yeah, it's a real challenge to know what to put in. I appreciate the thought. I appreciate the feedback, because it could be, I could see a place where people could get a better idea as to what some of the things look like. The connection or the tie-in is it's a tour of the museum. So I want to make sure that I highlight the things that are at the museum. So if you actually go to the museum, you would see it and go, oh yeah, I remember he talked about this. Oh, I remember seeing that in the tour. So that's my main drive, is to talk about things that are at the museum, because it's a tour of the museum.
Yes.
But I understand what you're saying. It's just hard to know what to include and not to include, because there's so much.
Yes.
So you're absolutely right. There's just an incredible amount of diversity that's out there. I just don't know that I have the space in it at this point to go really that much beyond what's in the breast piece.
Okay. All right. All right, I understand that.
That's my thought. I mean, that counsel is great and very well taken. If I was running short, I'd probably be all over it.
It's just was so fascinating, as well as the explanation of the pearls, because we've used for many years in Bible studies and also in the governing bodies talks about how the pearl is made in the oyster. So I personally appreciated the better clarification of exactly how the pearl is made.
Incredibly valuable and rare to find natural pearls. And it's kind of ironic in a way, because, you know, the oyster gets a little piece of grit in it and it's like, ouch. And so it puts the nacre around it to make it feel better.
Nacre.
But what it does is it makes it bigger. And now it's like, ouch.
Yes.
So what does it do? Puts more nacre on it.
Yes.
It makes it bigger. Ouch.
Yes.
More, you know, so it's a positive feedback loop that happens, and you wind up at some point with this big pearl. But the irony of it, it's the pearl trying to make itself feel better.
Yes.
In our wedding talk, the brother who's my uncle, he's since passed, but when he gave my wife and I our wedding talk some 45 years ago, he included that illustration about an irritant.
Yes.
So if she does something, try to make a pearl out of it.
Yes. 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 So what was completely new, we've never as a family heard this, is that if you put a shape of something in the oyster itself, it makes that shape in duplicates. So would you kindly explain that? Because that's scientifically unknown to us little mortals down here.
Well, you know, in all honesty, when I wrote this tour, when I thought about it, it's like, I want to do something to share some of the cool stuff I've learned with people that also like cool stuff.
Yes.
And to me, that was cool. I remember seeing somewhere all of these pearls in these different shapes, and they were freshwater pearls.
Yes.
You know, but in all of these different shapes, thinking, how did they do that?
Yes.
That was so cool that you could buy, you know, star shapes and, you know, just all different kinds of shapes.
Yes.
Diamond shapes and everything. You can make a necklace or bracelet or, you know, something out of these variety of shapes.
Yes.
So thank you, because you just let me know that the stuff that I think is interesting is what you also think is interesting. And that's very comforting and very nice for me, because that's the hope that I have, is that you find it interesting. The last thing I want is for people to go, wonder what's on TV, and then they zoom out, you know.
Oh, not possible. Not possible at all. My daughter is here. She had another question too.
Well, I just statement. How are you? I just wanted to tell you thank you very much for also helping us to understand about the epicenter versus the hypocenter.
Well, thank you. That's very, very sweet of you. Thank you. And it was nice that you invited your sister to watch it with you.
Yes. Exactly.
Thank you.
Bye-bye.
And interestingly enough, my dad was a scientist also, and he was a teenager. He was able to have, or maybe a young adult, I'm not exactly sure whether it was high school, I believe it was high school. He had a chance to have several classes with Einstein. So,
wow, he went to Princeton?
Yes.
Oh,
yes.
Wow. That would be kind of special.
It was indeed. It was indeed.
Yeah, I can hardly wait to talk to him when he comes back in the resurrection and find out about how good a teacher Albert was.
Yes. Yes, indeed. Indeed. Well, anyway, thank you so much for all of your wisdom and clarifications.
Well, it's not my wisdom. It's just no. So it's Jehovah's wisdom, but
indeed.
But I'm glad I was able to share what little I picked up and kept in my head with you. Thanks.
Indeed. We'll keep up with you in the future.
Okay. Thank you, dear. Bye-bye.
Appreciate it.
Let's see. This name looks familiar. Where have I seen this before? All right. What do you got for me, Severin?
Yes. It's not my mom this time. So yeah, so brother asked about diamonds for having like the breastplate. Now, not so much that it can make a diamond at the time not shiny, because they could make it shiny by hitting the diamond because they have cleavage planes. And so it'd make it shiny.
Run that by again now?
They could have made diamonds back then shiny by hitting it with the hammer or whatever.
Yeah, if they cleaved it, if they cleaved it just right, they could make it a little bit, but then it wouldn't be the right shape. It would, you would run risking not having it fit the right size and the right, general right area. And because the cleavage lines on a diamond are incredibly brittle. You tap it just the wrong way and breathe on it too hard, and it splits in half, and it's next to worthless.
And then also diamonds are generally smaller because like a 10 carat, it's pretty small. So for a breastplate,
that's a good point. That's a very good point. Yes, thank you. I will include that if that question is asked again. That is a very good point. Now, I don't know exactly how big, but the logic of that is if it was a standard size, then what was the chance of getting the standard size diamond versus all those other stones? They would be much easier to get those. And say it had to be 5 inches across. Of course, that's blown way out, but say 5 inches across. What's the chance of getting a diamond 5 inches across?
Yeah.
You could get all those other ones 5 inches across, probably okay. That's a very good point.
Because I did a video with all the stones for the breastplate, except the Lesham stone, because you can't really find that.
We're rock hounds.
Yeah. So have all those different crystals. So all those things mentioned there, like chrysolite, onyx, they're valuable all the time, and they can get at bigger sizes. So, and ones were familiar with it more back then versus a diamond was relatively new,
right,
in history.
Yeah, and you're not going to get one of a big enough size that's going to make it easy to process. So there were a number of obstacles to get diamonds in there. So thank you very much. I really appreciate you being here today to help, if you'll excuse the pun, polish the presentation. Okay, let's go with Chester King, the second. Or there's two Chester Kings.
Thank you. Okay, so can you hear me?
Yes, I can.
Okay, very good. Thank you so much. It was so educational.
Oh, you're welcome.
So detailed. I really enjoyed it. But my question was about Albert Einstein. I may have missed the answer to that poll question.
Okay.
So which statement was not true of Albert Einstein?
He was very good at math. A lot of people say Albert Einstein was not really good at math in school, but he was very good at math in school.
Okay,
he was just a little stubborn and a little bit irritated with having to do all of these multiplication problems. And I get that because I remember being in school and they would give us 100 multiplication problems. All right, look, I get it. I can do this in 5 problems. Why are you making me do 100 of them? And that's what he was irritated with.
Okay, yeah, good. Okay, good. Thank you so much once again. You was so educational. I learned so much.
Thank you. That's very kind of you to be patient and wait this long to let me know that. Thank you so much. Okay, last hand I see, Debbie Bolden.
Thank you so very much. I have always had a hard time trusting science because I remember being in school and everything was so, they just knew everything. And I knew they didn't.
Right.
But anyway,
but that's not just true with science. That's true with a lot of teachers that, you don't want to come across as not knowing your stuff because then you have discipline issues in your class. So for a lot of people, they have a natural pride that says, I remember so many times I'd ask a teacher a question and I could tell they were just trying to pull something out of smoke. They were just making something up. And yet as a teacher, I'm the first to say, I don't know. I tell you, that's a fantastic question. Let me do some work. If it's something I should know, then I'll apologize. I'm sorry, I guess I should know that. If it's something that's like out of the blue, like this boron, hexagonal boron nitrate, okay, I'm not going to apologize for not knowing that, because Tyler's the only one here on this deal that knows anything about that. But if it's something I should have known about, I'm going to apologize. But scientists in general, there's just a tendency to have a knowledge, but what does the Bible say?
Right.
Knowledge puffs up, right? But love builds up. And so you got to save face. So many teachers feel like I have to save face, like they expect me to know everything. And if they think I don't know everything, then I'm going to look bad. No, it's just like, hey, it changes all the time. Science is constantly readjusting itself when a better explanation comes along.
Well, you're making me love it more. So
okay.
I started loving it with the creation book and the creator book, but you're making me love it more. I'm subtitling this one From Jewels to Jewels.
Well, they're pretty and they sparkle. And
then they're also pretty energetic too.
Yeah, there you go.
From Jewels to Joules.
Gotcha. Okay. I got the transition. I got it. Thank you. In fact, I teach my kids when I teach about work, because work is actually in the same unit as energy. It's also joules. And I teach them, I say, jewel thieves got to work. So some of them kind of make the connection that, okay, jewel and work, and even though it's not spelled the same, jewel work. Okay. But I'm glad you made the connection.
Well, this is just a little enigma for me, and it's definitely tongue-in-cheek. But since E equals MC squared, how is it that 15 months into the staying at home, I have more mass but less energy? I mean, is that scientifically possible?
I think that's an apples and oranges thing. Besides, I know you gotta factor in all of the outlying things as well. But that's funny. I love it. I may work that in. I'm jotting that down because I can see a joke in that. I mean, well, you gave me a joke in that. Can I use that in my next tour?
Absolutely.
Okay.
I did.
Why don't I have more energy since I have more mass?
Exactly. So anyway.
Okay. That's got to be. Thank you very much.
Thank you.
I'll
so
put that
much.
in the next go around.
Really.
If E equals MC squared, why is it during the pandemic I have more mass but I have less energy?
There it is.
Okay,
That's scientifically possible. I just don't even know.
It's got something to do with the speed of light, I guess. Huh?
Okay, yeah. Yeah, the speed is gone. That's for sure.
That's it.
Well, thank you. You've answered that question.
Oh, well, you're welcome. And thank you for your patience and comments. Okay, take care.
Fantastic tour. Thank you so much.
Okay, let's see. Let's go with ciders. Two of them.
Yep, just one talking though.
Okay.
I was an educator for 40 years in many varieties of schools, public schools. The last schools I was an educator in was Montessori schools, and that was mostly private. And so the Montessori method was the fact that you started with a child at, infancy and went on just like what I felt in my heart about being a witness. And so it was fascinating to me that when you were talking about the phases of the moon and everything else like that, I did all that with 3-year-olds, 4-year-olds, and 5-year-olds.
Right.
And they caught on right away. We did dioramas of the volcanoes and things like that. So it's so fascinating to see, obviously you're doing it with older students, but actually when we started out with these little 3 to 6-year-olds, they got the concept right away. And it goes to show, it proves to show that from infancy on is when we should be teaching these things. So
I want to ask.
Oh, Tom, my husband wants to ask.
Jim?
Yay.
Wait.
Oh, my wife's getting this thing straightened out.
Okay,
here.
there you go.
Okay, Jim, been listening very interestingly to your presentation. You mentioned there that the center of the Earth, because it being such pressure, it's liquid, and you mentioned radiation there.
Right.
And I never heard of that before.
Yeah, that's part of the theory as to why it's so hot, is that you do have some radiation going on. I'm just sharing what they think. I've never actually seen it myself, so I'm just sharing what the thought is.
Okay, here's my question then. If that is the case, then lava that comes out with an eruption with a volcano, would that have some degree of radiation with it?
Probably minimal, if any, because most of that's happening deep core. Most of that is happening way down underneath the lava. But I would imagine there's probably some radiation, because it's a relatively common thing. It's just usually the dosages and the amounts are so small that they don't affect a whole lot of stuff. So we get so afraid of radiation because of X-rays, because we hear things about nuclear power plants and such. But you got to remember, all of those, the radiation is pumped up. All of those, they take the energy from the radiation and funnel it. But just in nature, you have radioactive decay happening all the time in a lot of different things. Different elements become different elements all the time, and it has minimal effect. But when you're down that deep in that big of an area and that much pressure and weight, you can just imagine all the weight and pressure that's down there. Well, any radioactivity that's releasing energy is just going to add to all the energy that's down there.
Jim, one more question, if I might. I'm just curious, all the cycles that Jehovah has set up, we have the rain cycle, we have the carbon dioxide cycle, oxygen and carbon, and the plants and so forth. I was just wondering, is this plate drifting and shifting, could that possibly be a cycle that Jehovah uses to replenish some of the things in the soil and to
yes. Scientists believe, number one, carbon. A lot of the rock that's gone down, sediment from animals that have died, their shells have carbon in them, and that gets subducted, that gets pushed back down into the earth. So part of the carbon cycle is thought to be connected with plate tectonics. So that one for a certainty. You're just other elements as well that are being pulled from the surface and being pulled back down could be part of the cycle as well. But I do know that I've read carbon as one in particular that's mentioned, to be able to take carbon out of the atmosphere, put it into some kind of an organism, and then that organism can be subducted as rock. So yes, a very astute observation. You're absolutely right.
Thank you, Jim. Appreciate it.
You're welcome. Thanks for the comment. All right, let's see. Okay. Well, I'd like to welcome everybody to the Tyler Severin Show. And now, here's your host, Tyler Severin.
Thank you. It's really his dad. Okay. I deeply appreciate your presentation, going through the Smithsonian like this. It's very much appreciated. I enjoyed how Einstein with E equals mc squared, how mass makes energy, but also how it goes opposite.
Yes.
Where Jehovah is one with vast dynamic energy. So you could take the equation of that energy and therefore it can convert into matter so that everything is here because of Jehovah's energy.
I guess I didn't do as good of a job of saying that as I thought I did. So thank you for that feedback, because I just made a note to make sure to go back and reinforce that thought, because that's exactly the point that I wanted to bring out. Jehovah's dynamic energy, all the stars were made because of Jehovah's dynamic energy. So thanks for that thought. I need to go back and pump that up a little bit to make sure that that's what comes out, is that everything that's created is started out as energy. And so that's Jehovah's energy turning into matter. So
And how
yes,
Einstein
didn't
even
do as
figured
good a
that
job.
out.
I didn't do as good a job of that as I thought I did, but I will go back and fix it. Thank you.
But Einstein figured that out.
Yeah,
the equation.
and you know what they say is in his mathematical formulas and going through all this kind of stuff, that C squared just kind of popped out of the math work, because they're still struggling. What has the speed of light got to do with anything? What does light have to do with this process, this transforming thing? And they don't understand, they don't know. They just know that whatever that number is, it's the speed of light squared. So why do you have to square the speed of light? Well, it just popped out that the number he came up with when he took the square root of it was the speed of light. But I've never heard any explanation as to the speed of light's contribution other than the number.
To make the equation work.
It makes the equation work, I guess.
That's it.
Okay, Tyler.
Yeah. So I just wanted to bring out a point about diamonds, since that was talked about a lot. Interestingly, that since diamonds ranked 10, like in the hardness,
yeah, and
that's only on one side. The other side you can actually grind and polish easily, because it's 100 times softer than the hardest.
We're talking about
so it's like
what can you
the
polish?
hardness for the diamond. The diamond itself is actually on one side of the plane is a 10 versus the other is like below sapphire in hardness.
Okay, you lost me.
Diamond. Okay, so diamond is ranked 10, but that's only on one side.
Well,
Versus
that's on the polishing side, but that's the only thing that's going to come in contact with anything.
Well, interesting for diamond cutting, that it is, they move it to where the hard can polish it very well. And so they hit the sides that are softer and keep the hard on one side. And so they can cut the diamond that way.
He cuts stones.
Yeah, I cut stones, that's how I know.
Okay, you kind of broke up on me just a little bit, but you're saying that only one side of the diamond is actually a 10?
Yeah. Yes, the hardest direction is the diagonal on the cube side, and it's 100 times harder than the softest direction.
Oh, okay. Huh.
So it has directionality in it. So,
well, I can understand making sure that you hit it on the right plane, because everything is about how it aligns. And the crystal structure on it has to be just right, because all the pressure's got to force it to have the maximum amount of space between your crystals, or between your carbons.
Yeah. Yeah.
So yeah, I'm gonna go back, and obviously I need to learn a little bit more about diamonds.
And it still can be cut on the 10, just like glass. If you get glass versus glass, you can scratch each other. So just take a lot longer.
Okay.
But they can still be done.
So that's why one diamond can scratch another diamond, is it scratches it not on its 10.
Yeah.
Cool. Well, thanks for that. Thanks for the info. All right, we're going to finish it up now with Dara Hagans.
Hello, how are you?
Hi there, I'm doing okay. You?
I love the tour, it was wonderful.
Well, thank you.
I have a question for you.
Okay.
Is Einstein's brain still around?
Well, you know, from what I understand, they sent it to different laboratories to see if they could discover anything about it that was unique. Several stories came out that it did have a high number of a specific kind of cell. It's not neurons, but what we call helper cells or nurse cells than the average brain capacity. But those samples, as far as I know, are still with the places they were sent. I saw somewhere that I think it was like 7 to 10 different places he sent little samples of it to see if they could see anything in it that was different from other brains.
Cool.
Now, an interesting thing about fingerprints is if you look at your fingerprints, there are several different types of prints that people have. One of them is called a whorl, and a whorl is like a bullseye. And Einstein had 10 whorls on every one of his fingerprints. He had a whorl.
Wow.
And the only genius I ever taught was a young man named James Ayers. This kid was just unbelievable, unbelievable. He had 8 whorls on his fingertips.
How do you spell that so I can look it up?
WHORL.
Okay.
Yeah,
Thank
and
you.
it's called dermatoglyphics. It's a study of fingerprints. Now,
Okay.
if you are an overachiever like me, you don't have any whorls. I have none.
Okay. Thank you so much.
You're welcome. Okay, last call for hands. Otherwise, I'm gonna finish up and go read the chats. Okay. So what I need for you to do now is to go home. Oh, wait, you're probably already home. Okay, let me rephrase that. I need for you to say bye-bye. So if you have a picture out there, wave at everybody. Thank you so very much. Thank you, Tyler and family. Appreciate it. Okay, I'm sure your Trivia Pursuit games are just as fun as our families are. Okay, okay. Take care, everybody. Hopefully I'll see you again soon. Love you all. Thank you.